The following is a presentation of the Six Arrows Radio Network.
Today on the Workbench, accurate frequency references and disciplined oscillators with Dr. Frank Howell, K4FMH. Stay tuned. Welcome to the Workbench. I'm your host, George, KJ6VU.
And I'm Jeremy, KF7IJZ.
This episode of the Workbench is sponsored by Elecraft, the makers of high-performance transceivers like the K3S, KX3, and the super portable KX2. Check them out at elecraft.com. And by Autodesk, the makers of Eagle PCB design software, the software we use to design all of our Workbench build projects. Get your free copy of Eagle at autodesk.com/Eagle today.
Welcome to this week's episode of the Ham Radio 360 Workbench podcast, your bi-weekly deep dive on technical and making topics of interest to the radio amateur. We publish every other week on Tuesday, but we are part of the Ham Radio 360 network, which consists of 3 shows total. So here you have the Workbench. On the Tuesdays opposite of us, you will find the original Ham Radio 360 show with Cale Nelson, K4CDN, the founder of the Ham Radio 360 podcast network. And on the Thursdays following Ham Radio 360, you will find our newest show, the Field Radio podcast with John Jacobs, W7DBO. This evening, I am, of course, as always, joined by my co-host, George, KJ6VU, and tonight our guest is Dr. Frank Howell, K4FMH. Gentlemen, how are you?
Hey, Jeremy, doing great from the West Coast, and good evening, Frank. Nice to hear you on.
Hey, great to be here, guys.
All right, so tonight we are going to be focusing on a topic that I've been really interested in for a long time. So Frank originally reached out to us back when we did our call for listener projects, and Frank had a really awesome project around accurate time. Some things happened in Frank's life, and he got busy, and we weren't able to connect at that time, but he sent us an email a couple weeks ago, and we were able to reconnect and bring him on tonight. And here in the second half of the show, we're going to talk to Frank all about accurate time. How do you do it? What is it? What do you need to buy? And most importantly, why do you want to do it? But in the meantime, George, what do we have for news this week?
Well, the big news, obviously, is all the hurricane activity that's going on in Texas and Florida and Louisiana. The whole Southeast is just being clobbered. And, you know, all of our best wishes and our hearts go out to everybody down there and to everybody who's providing emergency services to help everybody out. So that's what's on top of mind for pretty much everybody right now, I would say.
Yeah, and by the time that this airs on Tuesday, I believe Irma will have made landfall and have certainly gone through most of Florida, as this will be publishing Tuesday morning.
So, Frank, where are you located?
I'm located in Ridgeland, Mississippi, which is a northern suburb of Jackson, Mississippi.
Are you guys affected by all these hurricanes that are coming?
Not yet. And, you know, if you look at Irma, the jury is still out if it will skip over the Keys or Miami and go into the Gulf. If it goes into the Gulf, it's just going to gas up again and you know, Katie bar the door, as they say. But right now, we are not affected.
Well, hopefully it'll stay that way. By the time everybody's listening to this, of course, that'll be history. So hopefully it won't be as much of a disaster as being predicted. But on the radio front, Jeremy, one thing that I learned this week, I wanted to listen in on some of the traffic on HF. And there's multiple hurricane nets that are run on 20 meters and 40 meters. And I was able to do that with a web-based web SDR server. And there's apparently several of these around the world. So I thought it'd be good to touch on that briefly. But first, the nets that are happening on HF include a couple different things. One is the Hurricane Watch Net, and you could tune into that during the daytime on 14.325 and in the evenings on 72.68. So that would be one set of frequencies to listen to. There's also a lot of traffic on the Saturn Net, and the Saturn Net is on 14.265 daytime and 72.62 in the evening. And being that this is also a very coastal kind of potential disaster, there's also traffic on the Maritime Mobile Net on 14300. So those are good frequencies to tune into. And when I wanted to listen in, of course, I tuned my radio here on the West Coast to those frequencies. I didn't hear much. And it dawned on me there's probably some web-based receivers that I could try out. So I did a Google search for WebSDR, and it turns out there's a thing called WebSDR that I didn't even realize. And there's dozens of receivers all around the world which you can tune into and stream the audio at absolutely no cost. So I was able to use a couple of those stations to listen to the net traffic. So that was pretty interesting, and I really appreciate the fact that these guys make their systems available. Have either of you ever used the WebSDR?
I have a lot. I stream it to my desktop, almost daily, and it's a little bit of background noise while I'm doing my day job, which is a book editor. So I use it a lot.
Yeah, when I had first discovered it several years ago, I played around with it, and actually I hadn't used it in quite some time and fired it back up to also be able to listen to these nets. I recently got a random wire receiving antenna up in an upstairs bedroom, and which we'll talk about more here in a little bit, and wasn't able to hear anything. So it was cool to be able to pop around different receivers from different places to try to find the best signal. Now, George, you mentioned that there were two different nets. I had always heard of the Hurricane Watch net, but I'm not very familiar with Saturn. Can one of you explain what Saturn is?
Sure. Saturn is the Salvation Army, basically amateur radio network. And as it turns out, Bill Feast, whose call sign escapes me for the moment, we're in a club together here. He's located in Jackson. And that communications trailer, which is a fairly high-tech beast, will be leaving in the morning. But another friend, Mike McKay, N5 Delta Uniform, will be deploying through a base in Mobile, Alabama, to fly to the Keys to be deployed with some IT folks in that communications trailer. And he'll be there for 2 weeks. And so the Saturn net is a fairly effective net. I've had the benefit of using that communications trailer every field day because they work with us in the Central Mississippi Amateur Radio Association, and we usually have a large field day here. It's a very effective team, and they're very committed, and Bill Feast has done a wonderful job with that. The Hurricane Watch net, it'll sound like I'm a PR person for a moment. The Hurricane Watch net is managed by Bobby Graves, who lives in another suburb of Jackson, Brandon, Mississippi. And Bobby Graves has done a great job with the Hurricane Watch net as well.
So who is the organization that actually organizes the Hurricane Watch net?
It's just a group of hams, like folks that like D-Star, kind of have a either loosely coupled or more formally organized group. And it's just Bobby led the development of that a number of years ago, along with a few other people. And there have probably been some transitions over the years, but that's been a fairly dedicated group of people who just come together and say, hey, we need to do this, and we're going to do it. And there's no, nonprofit or, any other entity, to my knowledge, other than the group that have committed to working with the Hurricane Watch net. And unfortunately, they stay busy every year.
By the way, they have a website that I found. It's hwn.org for hurricanewatchnet.org.
All right. Well, we certainly appreciate the efforts of those folks making sure that there's opportunities to communicate in and out of these affected areas, as well as for other folks to get information about what's going on with the hurricane.
Hey, one other thing I want to mention on this WebSDR, I happened to be listening on 40 last night, and two guys were chatting, and one of the fellas was using a remote station. He was operating out of Illinois and running a remote station in San Marcos, California, down near San Diego. And so I could hear the station in San Diego really well. And so he was talking to another guy who is new to this idea of remote station operation. Well, the second fella, who's somewhere here in Northern California, he came up with a really clever idea. What he's doing, he lives in an HOA restricted area, has an indoor antenna in the attic. Sound kind of familiar?
Getting there.
And on my end as well.
Oh, no kidding. Well, so here's the clever thing. So he put in the wire antenna in the attic, and he said that he could make contacts okay, but that the noise level was really excessive. It was really high. So his big problem was not getting out. His big problem was noise. And then he realized that he could listen to one of the web SDR stations that's in the same part of the country. And he was using that as his receiver, and he was transmitting from home. So he was running essentially a split site. And I thought that is actually pretty brilliant, because if you could run, 20, 30, 40, 50 watts, you can get out okay, but maybe you have a compromised receive situation. And these web SDRs could be the way to solve that problem really well.
That is really neat.
It is. And let me throw in one thing. If you'll notice on some of the web SDRs, the capabilities there for any of them, not every web SDR site operator chooses to do so. But if you'll look, in many sites, you can record what you're hearing. And so one of the things that one can do, and I know some people who do this, if they're in some sort of RagChew or net or whatever, they can, on their desktop, go to different places, record themselves from different locations, download the WAV file, and then compare how they're getting out at that period on that frequency to these different sites. And yet no one knows you're doing that. So it's fairly unobtrusive.
Yeah, great idea. So I think this weekend, one of the things I wanted to do is see if I can record some of the hurricane net traffic and maybe stick that at the end of the show as a little bonus item if there's anything interesting. So we'll see if that comes together. But this web SDR thing kind of cracked me up because I didn't really know about this specific network of stations. And I just mentioned it, and both of you guys are like, oh, yeah, we know all about that. So apparently I'm the last one to find out. But I was pretty excited about it because, most of them are in Europe. They're all over the place. So if you want to tune around and see what traffic's like on 40 meters in Spain, no problem. You could easily do that.
Some will drop off on it. Some are experiments, and then, someone gets tired of it, and it does take up some bandwidth for them. But there are some that have been on there for, a couple of years or more, just from my own experience. And it's a thing.
Yeah, it really is. And what's actually kind of cool is that anybody who wants to, as I understand it, the software is freely available. You just have to have some receiving equipment. You have a lot of options, because I have noticed before, like in the earlier days when this launched, a lot of the stations on there would give you a lot of amateur bands, but they would only give you the CW or the data portions. They wouldn't give you the voice portions. And I don't know if that was because of bandwidth concerns or what. But, I notice now there's a lot more. There's also even several on there who give you access to like VHF and UHF in cities. So I think there was one in Michigan that if you wanted to hear the local repeaters up there, you could.
Birmingham, Alabama is the same. It's the same way. And I will, because of their propinquity to my location, I will often do that. I will tell you there's something that slightly predates Web SDR that's similar. The Perseus SDR receiver, the Italian company. I've had one for 10 years. You could put those online, and you kind of had to go through a website where they organized them. But, it was only the Perseus SDR hardware that connected there. And I've had one, but I haven't put mine online, and I haven't, gone to that one. But technically that probably predated the web SDR concept. But having said that, now you can put a Perseus on a web SDR node as well, but just a little historical note.
There's something else I found that I don't know much about. I just read a little bit on the webpage called Cloud SDR. I don't know if you've heard about that, but it seems to be a combination SDR receiver and the web server itself, so you don't need a PC or anything else. And I think it may be in beta. I don't think it's a released product yet, but they're supposed to release it later this year, by the end of the year. So you might take a look at that, Cloud SDR. And it's from an outfit called rfspace.com.
Oh, yes. They have pioneered some of the hardware for the U.S. over the years, and they had an early network SDR. So this is probably just the cloud outgrowth for the RF space receiver that you could put on a local area network.
Yes, I think that's right. Oh, I'm looking at their website now. They have a box called Net SDR Plus.
Mm-hmm.
Yes.
Another box called Cloud IQ, and some other stuff. So this is pretty interesting. I think this is a pretty fascinating idea. So we might have to come back to this as a topic.
Yeah, I was going to say
a postscript just briefly. I have former students that work for NSA at Fort Meade. Let me make a comment. There are two companies who sell hardware to NSA. One is RF Space. The other is Flex Radio Systems. I'll leave it at that.
Yeah, I was going to say, actually, the first time I came across these RF Space boxes is HRO actually carries them.
Do they really?
Yes. Yep. I saw a Net SDR in there many years ago.
Is RF Space located in a suburb of Atlanta?
Yes, they are.
Mark Holmes at HRO in Atlanta is probably the connection there for selling them.
I'll be darned.
Well, cool. All
well,
right. So,
I see I need to do a little more research and come back to this topic.
Oh, it's okay. We got Frank.
Well,
there we go.
Just happened to, some people have a lot of useless trivia, but so you have to ask them the right question.
Well, you're in the right hobby.
Yeah. And you're with the right people as far as useless goes. All right. So what else do we have on the news front, George?
Let's see. I also want to mention that our PowerFilm Solar giveaway was a rockin' success. So we ran that for a month, and a few people were still trying to register, and they couldn't. The page was down because the PowerFilm Solar guys ran it for a month and then shut down the registration page. So that's over, and I spoke with them this week, and we're going to get them on the show next time, and they're going to do the drawing and see who wins the 30-watt PowerFilm Solar flexible solar panel.
Cool.
Yeah, so that'll be great, and we are looking forward to getting them on the show beyond that to talk more about the technology and what makes their solar panels so cool. How do they get them so small and flexible? So quite looking forward to that. And you had an item you found on a new radio. I believe.
Did. And this is, so our friend Richard down at MTC Radio, a sponsor of Ham Radio 360, because of the number of IC 7300s that all of you bought from them, they were rewarded with a trip to Japan as a guest of ICOM to the Tokyo Ham Fair?
Yeah.
And so Richard and his family got an opportunity to go down there. I hope Cale's actually going to get some time talking to him. But Richard was posting a lot of pictures on Facebook. If you follow him or an MTC Radio on Facebook, or if you follow the Ham Radio 360 Facebook group. And one of the things that was initially confusing was there was a radio that looked like an IC 7300, except that below it, it said VHF, UHF, and 1.2. So what they have created, and this was an underglass model, and for those of you not familiar with ICOM product announcement lifecycle, the first time it's seen in public, it is underglass, meaning that it's probably at best a mocked-up prototype or a very early revision engineering sample. But this radio, it literally looks exactly like a 7300. It's called the IC 9700, and what it is an all-mode VHF, UHF, and 1.2 gigahertz radio with what we don't know all the details yet, but it has D-Star. And what I can only assume is that it has full D-Star capabilities. And what I'm hoping that means is the ability to interface the GPS as far as, loading automatic repeater data, the ability to do fast speed data, low speed data, Bluetooth interfacing maybe, and then it has 1.2 gigahertz, which if you've been around D-Star for a long time, there used to be a radio called the ID1, which was basically 128 kilobit per second data modem with an Ethernet port in the back of it, and this radio has an Ethernet jack on the back of it.
I wonder if that's just for remote control, or do you think that it might have the DD mode in it?
I'm going to think it has the DD mode in it because they still sell the modules for high-speed data. They've discontinued the ID1, if I remember correctly. I think, George, you bought some of the, in the last batch that were available.
Yeah.
But
they're gone.
It looks like, I mean, I don't, of course, again, it's under glass. There's not a lot of information about the capabilities. I don't know if it is like a direct sampling software defined, art radio architecture like the 7300 is. But all I know is that somehow at a date in my future, my 7300 needs a twin.
When I saw a picture of it or mentioned, I think on QRZ, I thought, man, I hope this is not one of those like April Fool mock-up things where some guy took 4 radios and like photoshopped one dream radio together and was like pulling the wool over our eyes. But this is a real deal.
Yeah, well, yeah. I mean, at least it will be once they fully announce like what the capabilities are. Like I said, it was under glass. There were pictures of some of the ports on the back, and of course, everything is subject to change. But it would not make sense to me at this point for them to release a D-Star radio that does not have every capability available to D-Star users now. But on top of that, it's been a long time since folks have released a VHF Plus radio that's all mode. So you're going to have sideband, CW. I'm guessing the radio has a USB port with a built-in sound card for digital modes. It looks pretty cool.
I'll be in Starkville at the MFJ 45th anniversary celebration later this month. In fact, I've been very honored to be asked to MC that program. Ray Novak will be there. I will do what I can to beat that out of him. Not everybody knows that Ray Novak's start in amateur radio, the commercial side, was as the international sales director for MFJ Enterprises.
I did not know that.
I had no idea.
Well, yeah, it's, if you can corner him, pull out your smartphone and get him on record talking about it. Because it looks like an exciting radio, but it was really cool that Richard shared that with us, and it was very cool that ICOM recognized their contribution to the hobby by flying him and his family out there. And I got to admit, I'm jealous. I mean, they ran the Hams to Japan promotion. I think it started around Dayton this year. But it was an opportunity for a regular ham to also win a trip to the ham fair. And, he took a picture of some of the older stuff there. Like, it wasn't just new radios. It was the Collins group that was over there. There was another classic radio group, which for the life of me, I can't remember what it's called, but it was old equipment, and it was a company I've never heard of. But yeah, it was neat.
And that's one of the things about ICOM. They do some things that some of the other big three, shall we say, or the other two in the big three, just kind of don't do. And they just have a really good touch. And Ray's been a big part of that.
I think they've done a great job. I mean, you could really try to compare all the big radio vendors, and, they all make good product and they all make a competitive product. And I don't think you can really say one is heads and shoulders better. But I think ICOM has really had a pretty high rate of change. A lot of new radios. They're really on their game. I think they're doing a bang up job, and I'd love to play with this thing. I'm curious what the price point's going to be. Well, my guess is probably close to $2.
I wouldn't think that. I don't imagine. Well, okay, so we're prognosticating at this point, but just given that the market price of the 7300 at launch was, I believe, $1,500 street price, I don't think it would be more expensive than a 7300.
Well, the only reason I say that is that usually the VHF radios, if they're only 2 meters and 432, then yes, I would agree. But since this has 1.2 in it, if it's built in and not an option, a lot of times the 1.2 options to radios are $500-$600 just for the 1.2 module. So if that's sort of historical pricing. So I don't know if the 1.2 is just built in or if it's a plug-in thing. I don't know. Well,
I'm hoping it's built in because I definitely agree with the normal expense. But if they built it into every single radio, then hopefully you get some economies of scale, and it'll. It would be interesting because it could make a low used band, which granted we're secondary users on, but it would add additional capability to folks. In fact, what's interesting is I don't remember if it's Diamond or Comet, but Diamond, one of those two companies actually make a portable, I guess you could call it, I don't think you'd ever use it as a mobile antenna, but they actually make a couple of antennas that are, D-Star tri-band antennas that have 2 meter 440 and 1.2 all in one big antenna. When I used to support the Marine Corps Marathon with my club back in the DC area, the aid station that I worked at, that's what my friend Rick N4ASX would always have, as one of those tri-band D-Star antennas up on a big 10-foot tripod. Well,
I've got a base station version of that kind of an antenna. It's 2 meter 440 and 1.2 here at the house. I can't remember if it's a Diamond or a Comet, but one or the other. In fact, that's what I was using on the DD module, talking up to our repeater was that antenna. But I'm glad to see another radio with 1.2, because 1.2 started to take off a while ago. So here in the Bay Area, there's several 1.2 repeaters. And over the last 10 years, the number of models of radios has kind of fallen off the cliff. And I'm glad to see something on 1.2. It's actually a very good band. It's kind of a better band than 900 because it's a lower noise floor, and the propagation is similar. Tends to be pretty binary. You're kind of like really in or you're not. But it's actually a very decent band. So hopefully we'll see more 1.2 gear, I hope.
Yes.
Well, guys, would you take a recommendation from the cheap seats for a new product that you'll talk about later? Have you seen the printer that will print circuit boards?
Yes.
No. About $3,000. Hopefully that'll come down.
What's it called?
Wow. I wish I just saw the picture, and it looks like a little 3D printer and all that, and I'm not helping you out at all on giving that answer. But I tell you what I will do. After our recording, I will Google that and send you the link for the show notes, since I brought it up. But I do hope that it's a future session here, you'll talk about that, because it follows along with your general narrative just superbly.
Interesting.
So here's a quick Google. Tell me, Frank, if any of these sound familiar. Volterra, Bot Factory, or Dragonfly?
Volterra, I get the best vibe from. But it's
$3,500.
That's in the ballpark.
Yeah, it says prototype on your desktop with a Volterra V1 PCB printer.
Mm-hmm. That sounds like it. And of course, you'd expect that to drop under 3,000 if they, start selling the things. But, and that's a little pricey. But on the other hand, to design it and make it, and it's there, if you're doing a lot of stuff, not bad, because there'll be competitors, and that the pricing will come down some.
So is it printing the pads with some sort of ink, or is it more like a Dremel thing that's cutting away mechanically?
I don't know, but boy, the press release sounded like you want a circuit board, input the information, it'll spit it out. Now I know that's kind of the rookie mistake that most people read when they see a nice picture, but when I did read that, it did sound like it's going to print on a board. I stand to be corrected.
So the way that this says it works is it puts down a conductive ink, and the print surface is heated. So it dispenses conductive ink and then solder paste. And you can also apparently use the print bed to reflow the solder. And for all I know, this very well could potentially, and maybe there's a pick and place type head for it in the future, but looks like minimum, I'm trying to find, so it prints on FR4, 3mm or 0.125, and I'm trying to find the print bed. The maximum area is 5.3 by 4.4 inches. With a maximum temperature of 464 degrees Fahrenheit. So, and it looks like this says you just load the Gerber into it and boom. But how about I blow your minds?
Yeah.
How would you like to do something very similar for $300?
How do you do that?
So it's very funny because a friend of mine at work who has become a listener, my friend, the gentleman from South Africa who was my mentor for 3D printing, So we had a little like a electronics lunch and learn group for a while. And for one of the sessions, he brought in a desktop CNC machine that he had built. And the tool head was basically a little Bosch trim router. And he has, there's a plugin for Eagle, or maybe a second application that will take your Gerbers and convert them into G-code. And then you basically put a piece of copper clad board and it will etch away the parts that do not need to be conductive. So he's able, and there are desktop CNC kits available. And I actually talked about one in an episode a long time ago, and it's one he mentioned to me. That was a guy who had done a very successful like Kickstarter one called Shapeoko, which I think is on its third or fourth generation now. It sells for about $1,000. But they started another one called I think the Millwright or something like that, and that kit's available for like $300 or $350. And so he does a lot of electronics projects on the side, and that's what he does. He's actually never sent a board off that I know of to like a PCB manufacturer like Osh Park or Seed Studio or anything, because when he needs a board, it's almost always for a prototype reason. And so he'll just run it through. And, today we talked a little bit about the differences in thought, because obviously, George, when you're ordering a board for a Workbench project, you have the ability to order a double-sided board, or you could even go for a 4 or 16 layer board if you wanted to. Whereas if you're milling these yourself, you have to think a little bit differently about board layout to either keep everything on one side, or to realize that where you would normally need vias, you may have to use something like a 0 ohm resistor and then solder it on both sides of the boards to get to the contacts on the other side.
Yeah, I was just thinking that the one missing component is you can't plate through the hole, so that would be a bit of a trick. If you use through-hole components, that solves a lot of the problem, but you'd have to figure out where to poke a wire for that. Which is the way we used to make circuit boards 30 years ago in our garage.
All I remember is going to Radio Shack and being able to buy those etching kits that came with the special marker, and then you had the tank of acid and ugh.
Yeah, exactly. A friend of mine designed a repeater control system that was pretty phenomenal back in the late 70s, and he made his own circuit boards. And I went over to his house one time to help him stuff some boards, and I said, "Well, how do you etch this stuff?" And so he says, "Well, you do the layout on some acetate, and you expose it, and you etch it, and now you got the etched board." And like, what do you do with the etchant? Oh, you just put it down the drain. And I was thinking, wait a minute, if you have copper pipes, you're pouring your copper etchant down it's a rental house. Now I understand it.
And, the owner. We have all kinds of things in our water these days.
Yeah, no kidding. Oh God. Anyway.
I know.
Well, that's pretty cool.
Yeah, and on this topic, I mean, I don't remember what it was called, and I probably wouldn't be able to find it. But I know there was another device that was announced, I think 2 years ago, that was meant to be like a true rapid prototyping machine. Like, it had different tool heads, so you could print your own circuit boards, and then you could put a different tool head on it to basically be a heated extruder for traditional 3D printing. But well, I'm not going to say anymore because I'm going to cover something when you ask me about my Workbench.
So, Jeremy, what's on your Workbench?
We're the worst at segues.
Well,
hey, by the way,
he a compliment along the way. What you guys just did for a consumer of your podcast like me is very enjoyable, because you have a good chemistry together. And when the topic comes up, you guys ping off one another very, very effectively. And the listener to your podcast learns a lot.
Well, thank you.
That's very kind of you to say that. So actually, when Jeremy and I first started talking, we were pretty good at just BSing at each other. Hey, this went pretty well.
Well, having been a professor for 40-something years, I'm familiar with both sides of that coin.
And I don't mean a Bachelor of Science.
Yeah,
I understand.
So speaking of BS, Jeremy, what's on your Workbench?
All right, so I actually have two projects, and I think they're both very cool, and both actually related to things we've talked about tonight. So, first of all, lately a lot of what I've been talking about that I've been playing with is I've been playing with my AirSpy software-defined radio receivers. I own two of them. I own one called the R2, which is 24 megahertz to 1.8 gigahertz, capable of showing up to 10 megahertz of bandwidth simultaneously, 8 megahertz of unaliased bandwidth. And the AirSpy Mini is a little like a USB dongle sized one that's capable of showing up to 6 megahertz of bandwidth, 4.8 megahertz unaliased, but also that 24 to 1.8 gigahertz range. There is a converter available that gets powered by these devices that gives you access to HF, and they have a third device coming out called the AirSpy HF Plus, which will actually it is really designed from the ground up to be a very sensitive and selective HF receiver, all the way up to 260 megahertz, but just very low bandwidth, like 768 kilohertz of bandwidth at a time. But anyway, so I've been playing with these, and Frank, I think you kind of alluded earlier, you may also live in an antenna restricted area.
Yes.
Okay. So you're familiar with some of the frustrations and creativity required to mount things out of the way or hide them or put them in an unused bedroom. So I have a room in my house that used to be my infant son's nursery. He's moved out of it. It's smaller than the room I'm in now, but it will eventually be my office someday. And I had an old laptop it's like an ancient that I was using as a host. As I mentioned in a previous episode, the maker of AirSpy provides a piece of software called Spy Server, which is basically a server application that runs on Windows, x86 or x64 Linux, but then they also make a 32-bit version that runs on ARM boards like a Raspberry Pi or an Odroid or, of course, a Tinker board. So I started experimenting because the Raspberry Pi USB implementation is a really an unfortunate limitation of Raspberry Pis. The CPU and memory and everything has plenty of horsepower to probably serve as a host for this, but the USB bus is shared with the Ethernet controller, and there's an onboard hub, and it just cannot support more than about 2.5 megahertz of bandwidth. So but anyway, there's instructions on the website to download all of the driver and host software and the modules, and you compile them yourselves, which is pretty easy. I'll include a link to that again. But so anyway, I've had this Tinker board, and I think also in a recent episode, I talked about how disappointed I was with it. And I decided, it spec-wise, from a USB perspective, should have had plenty of horsepower to both run Spy Server, but also have enough USB bandwidth to give me full access to the bandwidth of both the AirSpy R2 and the AirSpy Mini. So I installed the stock Linaro OS image available from the Tinkerboard website. I set it up so that it only booted into command line and didn't launch X and everything. And I got the software compiled, and I got Spy Server up and running. And I now have this board upstairs, this little tiny Raspberry Pi size board, and it has both my R2 and my Mini plugged into it. So my R2 is connected to a Discone to give me VHF and above, and the Mini is connected to the Spyverter to give me HF. So I've got a Discone up there, and I last weekend I actually had a chance to visit Universal Radio in Columbus, Ohio. I picked up some wire while I was there. I took a 35-foot length section and taped it to the wall in the room, and I now have a receiver upstairs that I can connect to with any computer virtually in my house from anywhere in my house.
So you have your own web SDR.
Yes, except the web part is not there. You still use the SDR Sharp software provided by the manufacturer to connect to it. Although I actually just learned he released some example code that if in theory you could take his example C code and potentially develop like an iOS app to connect to his Spy Server. But it's neat because I have two instances of Spy Server running on two different TCP ports. And depending on what port I connect to, it gives me whether I get the VHF and above or the HF. There's not enough bandwidth to run them both simultaneously unless you ran both devices in their slower bandwidth. So for the R2, that's 2.5 megahertz of bandwidth, and for the AirSpy Mini, it's 3 megahertz of bandwidth. Because it seemed like the total, based on some of the tools they give you, the total bandwidth between both devices, the most the USB bus could do was about 12 megahertz. So it's still pretty cool that I have a credit card size computer upstairs running off a USB power supply with a fan, because it does get super hot in the therm. Like, it should have come with a fan, but it doesn't. But it's just a little module. I have power run to it. I have it plugged into the Ethernet jack in that room, and those antennas are just up there. And I can now listen to stuff quite freely, like I said, from any PC in my house. It's really cool.
That is cool. The interface for radioing is really evolving, isn't it?
Oh, yeah, it is. Now, some of the other SDR applications out there, like Power SDR, people have done, work to make things MIDI compatible. And MIDI is a very old standard. I think it's the Musical Instrument Digital Interface, and it's basically a serial standard for providing control data to devices. So like MIDI keyboards, you press a note, it sends data. And I know, like, I've seen projects where people have adapted like MIDI mixers or MIDI DJ consoles to basically act as ham radio controllers for things like Power SDR for some of the Flex radios.
I actually have one for SDR Console 3, which is Simon Brown, the original author of Ham Radio Deluxe, his current project. And he uses CMD PL1. I'll have to turn away from the mic, but it's Behringer, I think, is the manufacturer. And I use that with a big platter on it for my Perseus or my RS Play. And it works fine, but it is what it is. It doesn't do more than what it will do. But they're very popular in that genre of work.
So when you say a big platter, this is like a DJ mixer, and so it looks like a big, like a record pad?
Well, it's a funny device because it's a tweener. It's not the big one that you're thinking of, that the guy from Germany, whose name escapes me, but who really did a lot of work with the MIDI SDR stuff for Power SDR. And I'm just blocking his name. It's not the one with the dual pads, but the CMD PL1. And the reason I did it was because that's what Simon himself is using, so I know it will be supported. It's kind of half of one of those things. It's not quite the size of an iPad, but about like that. And there's a pad that's used just to tune and things like that. I don't do DJ stuff, so I don't know that lingo or why it's actually built, but I know what I'm using it for. And it works great. I mean, I've had a Woodbox Teammate 1. I mean, it's milled, it's great, but it's no longer supported. The Teammate 2 is, for example. And so there's just kind of a lot of turnover in that space. But not to get away from your main point, it is an old standard, and its half-life will be nearing an end.
Yeah, and the one of the downsides for SDR Sharp is technically, if somebody wanted to, they could develop a plugin for SDR Sharp to add MIDI control capability to that application. About right now, I've seen plenty of projects where people will cannibalize like a wired desktop mouse, because by default the scroll wheel will act as a tuning dial. And I actually saw there was a guy who took the rotary encoder out of a mouse. He left all the mouse electronics intact. He just turned it sideways and put a big weighted knob on it. So he has a knob.
I've seen that.
Yep. So,
I think I was just going to say, if for people who are listening and have no idea what this thing is, I had looked this up once before because someone had referenced it. I had no idea what it was, but it's an accessory. It's a box with a big, it's like a shuttle control knob and a bunch of push buttons. And I guess it's all software configurable it's on a USB cable. So I guess they wrote a driver. Is that what, for what they did on the receiver? So you USB this thing into the PC, and this is the mechanical knob that you could use as the tuning knob, right?
Yes. As long as the MIDI mapping to the software has been written. And you can light up all those buttons. Now, I have not. I've been just kind of copying what Simon Brown, the author of the SDR console version 3, has done, just to kind of be copycat and follow him. But yeah, you can map all that stuff. It just depends on how much you need. And again, to be negative on it for a second, you get a big learning curve into it, and then boom, things change. And so then you've got to kind of go another direction. So I'm kind of in the middle there. I'll use the basic functions, and it works very well. I've also tried the little what's that little silver knob that they don't write drivers for anymore?
Oh yes, it was just the USB knob.
Yeah.
They don't have drivers for the new Windows versions for that thing. I know exactly what you're talking about. So if you look
at all those things, people that have been using them for SDR stuff, they've kind of had to shuffle around, and there's not yet a great solution. But I don't want to pull you away from your point. I agree with you. The MIDI, the half-life of the MIDI standard, if you will, is nearing the end of its cycle.
Yeah, and I think it's interesting to hear you say that. But George, if you're not familiar with MIDI, basically, I mean, the standard really is like 30 years old, and there's like different classifications of messages. Like there are note messages, and the note will have a velocity value and like some other parameters that can be sent with it. But then what ends up happening with things like these controllers, there is also a concept in MIDI called I think there is CCs. I think that's control changes. So these interfaces, it's not a driver for the specific box, because the box is designed with whatever buttons, knobs, faders, scratch pads, whatever. Generally speaking, there's a host application that lets you go in and say, when I push this button, I want you to send control change 22 on channel 2, and then these are the values. And it may be binary, it may be every time I push it, increment it once. So at the receiving side, if it understands MIDI input, which MIDI is just a serial protocol, if it understands MIDI input either from hardware or from software, it can interpret, I got, control change 22 on channel 2, and this was the value, therefore respond to it this way. It's cool that we wound up going down this road, because this is actually incredibly pertinent to the other thing that's on my workbench. And this is something that I thought I was excited about 3D printing. And I am a kid in a candy store right now on this next one.
What would that be?
Thank you, Frank. So, George, in the last episode, and I don't remember if this got caught on air or if this just happened in the off-air conversation with John, I made the comment that since moving to this new computer, I no longer have my nice, gentle touchpad that was on my Mac, which when I'm not talking, I generally mute my channel. And the problem that I have now is that you guys, you can hear the mouse click, right?
Yes.
So,
right.
We talked about, for anybody with a broadcasting background, you're familiar with the concept of a cough button that's generally put in the console that the
right.
guest can hold, and it mutes the microphone. John had mentioned to me that there were a few available from a company that I know and trust. I went and looked at them, and what they do is they don't disconnect any lines from the microphone, from the mic input. And I understand why, because depending on how things are built, there could be popping. And you certainly wouldn't want that to happen. What they do is when you press the button, it basically inserts anywhere from a 20 to a 60 or 70 or 80 dB pad on the signal. So it's basically taking the level way, way down, but it may not be enough. And at the end of the day, these boxes range anywhere from like $60 to $200, depending on, how good of one you buy. And I thought that's ridiculous. I need the functionality for a silent button, but given that I am the host of the Workbench podcast with you, I wasn't going to solve this problem with mechanical stuff, because George and you and I have very similar setups that we use to record. And the one thing that you and I have that's identical is you and I both use a Behringer XR12 digital mixer.
Yes, we do.
So these mixers are completely software driven. There are no faders or knobs or switches or anything on it. It's literally a 2U rack unit of inputs and outputs with a built-in Ethernet controller and a built-in Wi-Fi interface, and you run software to connect to the mixer to configure it. And like right now, I see the application up on my screen where the mute button is. The cool thing is I found a MIDI control guide for this mixer. So I sat down, I started Googling Arduino and MIDI, found that Arduino.cc, like the official Arduino folks, actually had an example of how to build a circuit. And for this case, I just needed a MIDI out. MIDI is serial data at 31250 baud. And basically you use there's a 5-volt line that runs through a 220 ohm resistor that goes to the MIDI jack. The data that goes over on the serial data out from the Arduino goes through a 220 ohm resistor, and then you have ground. And the reason that you have a 5-volt line is the input to the device is opto-isolated. So you need the 5 volts to drive, to power the LED on the other side. So I sat down last weekend. I, pulled out an Arduino Pro Trinket, which is a $9 30 or 328 based Arduino. It has more than enough pins for this project because at the end of the day, all I needed was a pin for the button. I needed pins to be able to turn an LED on and off so that I would have a visual indication of whether I'm muted or not. And then I needed to use the serial transmit pin to send data over to the thing. So I wired this all up in a breadboard, got it working fantastically. And I said, that's not enough. And so for the first time ever, I pulled out Eagle and I sat down. And thanks to the fact that Lady Ada actually makes her personal Eagle library available on GitHub, I was able to find an Eagle component for the Pro Trinket. I was able to find an Eagle component for the custom MIDI jack that they sell. And then, so I sat down and was really frustrated that it wasn't apparent to me how to do schematic capture at first. And so here's the pro tip. And I'm going to say this, and it's going to sound really stupid to somebody like you who has a ton of experience. You don't draw the connections. You use the net. Net is the type of connection.
Good point.
I know that sounds so simple, but that stymied me. And as soon as you do net, all of a sudden the little bubbles pop up on the connection points. While I was doing this, I was posting stuff on Twitter, and Smitty and Kenneth, KWF, were online. They hopped on a Google Hangout with me, brought the schematic up. They gave me some very good feedback and showed me some errors that I had made and explained to me why to do things a little bit differently. They gave me this great idea that rather than only run out the pins to the LEDs and switch that I need, go ahead and put in 2 rows of header pins so that anybody could use this for their own MIDI project and have access to all the pins already. So I have the schematic captured. It is a valid schematic, and tomorrow I'm going to start board layout.
That is awesome.
And once I've gotten the board laid out, I'm going to send it off to Oshpark because I have some friends who were very kind to give me a coupon over there. And so basically they charge like $5 per square inch for 3 boards. So the board that I'm going to wind up doing, I think, is going to be approximately 1x2. And it's a 2-week turnaround time. And I'm going to upload the Gerbers. I'm going to get these things back. Once I get it back and actually get it soldered together, I'm going to go over to Autodesk Fusion 360 and design an enclosure for it. And I'm going to assemble this all. And then what will have happened at that point? And I'm literally tingling right now. I will have found a problem. And I will have designed, programmed, and manufactured a gadget completely from scratch to solve that problem.
That's awesome.
There's only one word from my point of view, and that's bravo.
I mean,
indeed.
The button that I use is a little Adafruit 24 millimeter arcade style button. So the button's completely silent. And actually, when I bought the button, I didn't realize this. The button actually has LEDs in it. So I don't even have to run separate LEDs or do anything to hack to put LEDs in it. Like I bought a red button and it has red LEDs in it. When I press it, those LEDs come on. And so if everything works out, George, I'm going to be sending you one of these mute buttons. Woo! Since you have the same mixer. And then I plan on putting the source code that I used, which I used some of the stock like Arduino debouncing examples and, basically a lot of open source stuff online. I'm using pull down resistors, and I'm just so excited that I'm building my own gadget from scratch.
That's very cool. You know, what's really useful too in that kind of a scenario is, since you're doing everything, including the chassis, when you write this up as an article somewhere, that'll be a great thing for people to see how you could do the whole thing. Because a lot of times you'll see a project and think, okay, well, I could figure out how to do a part of it, like maybe print the case, but I got no idea how to do the board or where to get the parts or where to, pulling it all together is great. Are you 3D printing the box?
Yes, I will be. I haven't started designing it yet because it would make no sense to start designing it until I see what my final board layout will be. And honestly, I don't know that I'll get it finished this weekend, but fully expect several questions emailed your way, because there's a lot of stuff that it's going to be a two-sided board. And it's really, my friend that I mentioned earlier who has the ability to use the CNC machine to make boards, he's like, hey, do it one-sided, send it over to me, and I'll etch it out for you. And I explained, I said, part of this challenge is actually trying to start learning how to think about having two planes of conductivity and how you have to interface, get signal from one side to the other side, or power or ground from one side to the other side. And so from the learning aspect of it, once Smitty and Kenneth kind of set me right on the schematic part, like all of a sudden that kind of became kind of easy, as long as you don't have to design your own custom components. And even that, I'm sure once you know it, it's easy. But this is going to be a phenomenal learning experience. And you're right, I do hope to take the time to write it up, top to bottom. And then the design will be open source. The case will be open source. If somebody wanted to actually take this Arduino and if they had a hardware a MIDI interface for their computer, they in theory could use this and customize it and put rotary encoders, or could put buttons of their own or whatever, and make their own custom radio controller for one of these SDR applications that support MIDI interfaces.
You know who'd be a good person to bounce that off of when you get it done? Is Glenn Popeil, who lives up this side of Memphis, who did the 2 books for ARRL on Arduino.
Well, very cool.
He's not the same one that had the pocket fisherman, is he?
I've asked him that, and he just frowns at me when I do.
Sorry. I'm sure no one's ever asked him that question.
It slices, it dices, it makes julienne fries. So yeah, that's what's on my workbench.
I'm very excited about that. I shoot me any questions you got. It sounds like you got it pretty well in hand, though.
Well, but there's there's going to be a lot of best practices. So I'll ask you one question that came to mind. What's the minimum margin for putting holes towards the end of the board, or towards the edge of the board?
Well, it really depends on what your manufacturer will allow you to do. So the manufacturer of the circuit board will give you the tolerances that are their smallest drill hole size, the distance to the edge of the board, and all that sort of thing. So you'd really have to refer to the manufacturer. But just to be on the safe side, I would probably stay a 1/16 of an inch away from the edge of the board, or less. Okay. Or more from the edge of the board. Because you want to make sure that when you put a donut there, that the donut doesn't go off the board. A lot of times, if you submit a circuit board to a fab, they'll run a design rule check against that board layout, and if there's something like the pad that gets soldered to, if it goes out of the dimension of the board, sometimes that'll be flagged as a design rule error, or sometimes they'll fabricate it that way, and maybe you wanted it that way, but you just stay 1/16 of an inch away from the edge, you're fine.
Okay, that's a good guideline.
But there's a lot of little things that people do that are, sometimes they're mistakes, and sometimes they're just not really the best way to do it. Like they'll make the traces too thin, or they'll make the vias too small. And electrically, it may be sufficient, but if you want to make a more robust circuit, the bigger the traces, the bigger the pads, the more reliable the circuit will be. Another really common thing is you'll have 2 traces connecting, and if you have an acute angle. Let's say, for example, you have a horizontal, like you're looking at the layout, you have a trace that's horizontal, and then you have one that's not 90 degrees off of it, but maybe at a 45-degree angle, creating an acute angle. That electrically it's okay, but from a manufacturing reliability point of view, that's not shouldn't be done, because those acute angles create little pockets where etchant could get stuck, and that's against like mil-spec design. So if you're really like picky about stuff, you'll avoid that sort of thing. So, but a lot of these things are just stuff you learn after you make a lot of boards.
Well, so since you brought it up, what's the via size that I should use?
It's really a function of the amount of current that you're pulling through the circuit. So you have very little.
Yeah.
So the reality is you could probably use anything down to the smallest via and trace size that the manufacturer supports, which is probably a trace of 0.01 inches or maybe down to as small as 6 mils on the smallest side, but that's really tiny. And then drill hole size maybe 0.01 inches in diameter, but again, 10 mils is pretty tiny. So what I tend to do, if I have a board with plenty of space and I don't have to worry about congestion or packing a bunch of stuff in there, I'd probably use a 0.03 inch wide trace, more or less, and maybe a pad with a drill hole of 0.03 to 0.04 or something like that. That's kind of plenty big enough for power and signals and anything else. So, of course, you can make them half the size, and it'll be fine for small signal stuff. It's really not a big deal. What really dictates it is the amount of current you're pulling through it, the length of the trace, so you don't have any voltage drop, and the congestion. A lot of people will. Another little tip, a lot of people will ground fill around their signal traces, which is fine. And with Eagle, you can tell the software how much of a gap between the signal and the ground fill. And the default is very tiny. So you'll have this super small area between your signal trace and the ground fill. And if you have any solder flashing over at all, then it has a potential to short. Now, the saving grace is that ground fill is covered with solder mask, so probably won't short. But the defaults are too tight, and you kind of want to loosen that up a bit. But what we'll do, Jeremy, after you do the board, we could bring it up on the screen, and I could take a look at it and tell you if I'd do anything different. But
I would love that.
Yeah, that'd be great.
Yeah, I mean, that was really helpful when I did it with Smitty and Kenneth. But I mean, I'm going to say this: if I can do it, just about anybody can. So, but more to come. Like I said, I hope to get time this weekend to work on that. And I know it's not strictly ham radio related, but I'm using these tools to solve a problem.
Well, the beauty of that is by the time you're done, you'll know the 18 steps from concept to done. And now when you have some other project like your band pass filter switch box or whatever you want to build next, then it's just a matter of designing the new circuit and adding a few new parts, but the rest of the process,
Yeah.
Let me build on George's comment. What I used to tell every PhD student who said, "What should I do for my dissertation? I'll be known by that forever." And my answer was, "It doesn't matter." And they would look, "What do you mean it doesn't matter?" I said, "Because you will do as George just said. You will learn to become excellent in something. And once you have done that, you can become excellent in anything."
That's a really good point.
Yeah, that's a great call out.
And the thing that the worst thing you could do is don't do it. Don't do anything.
Yeah.
And it's so easy to say, "Oh man, I don't know. I don't know where to start." But these days there's so many examples, whether it's coding or board layout or mechanical design. There's so many good software packages out there for free. There's so many YouTube videos. I mean, geez, this is like the golden age of learn to do it.
Yeah, I mean, 10-year-old me is giddy with excitement.
10-year-old you would not have made a mute button. You'd make like a M&M launcher
or a robot. But anyway, that's enough about me. George, what do you have?
A beer launcher. That's the 18-year-old me.
Not your 18-year-old workbench. What's on your 432-year-old workbench?
Well, let me tell you, son. So I got a couple things on my Workbench, two of which are actually kind of in a similar vein to what you're talking about. We'll get to that in a sec. So first thing is I've been working on my KX3 portable station box, and I posted some pictures of this stuff on the Facebook page. And I got to tell you, I'm really happy with the way it's going. So long story short is this is the sort of shelving unit. It's about 18 inches wide, about 10 inches deep. And the KX3 and the PX3 are mounted to that. And then there's about a 5-foot end plate on each side and then a shelf across the top. But the shelf is not the same depth. It starts about 2.5 inches in from the front. So you can see the radios. They don't get covered up by the shelf. Anyway, and I put on a bunch of power pole connectors and voltmeter and switch. And there's room for a bio-NO battery inside, which I normally don't do. But anyway, that thing has come together. I went to Tap Plastics, got a piece of 16th inch clear plastic and screwed that to the top. So the wood looks beautiful, and I could put something on top of it and it won't mar up the surface. So I'm really liking that a lot. And I started working on the equivalent case for the KXPA 100 amp and tuner. So there'll be a companion unit. So I think I finally figured out the form factor, at least for this year, for the portable station. So the proof's in the pudding. If I get to field day of next year and use it and still like it, then I think I will have cracked the code for myself. But it's been fun to figure this out, and it's like the 14th different kind of radio box contraption that I've built, and I like it the best so far.
Good.
So that's moving along. The other things on the Workbench are more electronic design projects, and both of these I've posted on the Facebook page. So a couple weeks ago, I made a remotely controlled link dipole antenna link. So for the Pactenna, it's a link dipole in the classic Pactenna. So it's a resonant antenna. We make 20-meter segments, and you can put two of them in series on each side of the inverted V. And if you connect the link in the middle, it's 40-meter inverted V. And if you break the link, it's a 20-meter inverted V. And that's all great. And when you want to change bands, you just lower the mast and you make or break the connection and jack it back up. So that's all fine. It's not a big deal. But I thought it'd be cool to be able to remotely control that. So I took a microbit, which is the very popular controller I mentioned on the previous show. It's got an ARM processor and a Bluetooth radio and some other peripheral chips in it. And I made a custom circuit board with a relay and the same kind of connectors we use on the Pactenna. And there's one of these microbit microcontrollers and relays where the mechanical link goes in the link dipole. And then you have a third one of exactly the same thing, and it's got two buttons on it. You press one button, and it sends a message over the Bluetooth radio to the links and says, connect the relay. You press the other button, it sends a message that says, disconnect the relay. And the relays are latching relays, so they draw no power when they're just sitting there. So put that together, tested it out, works great. I need to finalize the exact right length of the wire for the antenna to get it right on the frequency I want. But that's been a really fun project. And if anybody wants to do any coding who's never done any microcontroller coding, I would seriously suggest looking at the microbit because the coding environment is very simple. It's as easy or easier than an Arduino. I don't really want to say it's better or worse than an Arduino. It's very similar, but it's a different thing, but similar in concept. So that's a cool project, and there is a bunch of people interested in getting boards, as it turns out. So that may turn into a build project later this year when I have time to work on that, finish it off.
George, one comment from the cheap seats. Just like the buddy pole kind of blew up and became a thing, this has the potential for that.
I would hope so. I mean, I think it's got some potential. In fact, you could take this remote control concept and do it with other kinds of antenna configurations. I was thinking like
exactly
a vertical. I don't know, if, Frank, if you remember the old verticals that had the big loading coil at the bottom, and just like put the alligator clip somewhere to tap the coil.
I have a couple from MFJ that Martin built just to kind of make something one time. Yeah.
So that's a very simple antenna, but instead of moving the alligator clip, you could put one of these little controllers there with a bunch of relays and just remotely select what tap on the coil you want.
Exactly.
So I'm thinking, boy, this is actually kind of a universally useful thing. So I think there's a lot of ways we could take that idea. So the only limit's really time.
Well, I have a question.
Yeah.
The microbits. So for those of you who've not seen them, the edge of the microbit actually looks like a Nintendo cartridge. It has these giant contacts on the side. And I know, George, you had posted a while ago, you had managed to source some, I guess we'll call them slot connectors that, give you access to the individual pins. So is that how you're interfacing the microbits with these boards?
No, actually, not on this project. So this is a really clever idea. So at the edge of the circuit board, everybody's seen the gold card edge connector kind of thing, where there's a bunch of little traces run off the edge of the circuit board, and then that plugs into a card edge connector. So what you're describing, Jeremy, and there's about 20 pins along the bottom of the microbit. So they did something very clever, which at first I didn't really understand, but it finally dawned on me why they did it. When you look at the circuit board, you'll see that rather than having just 20 skinny little wires, they've got or traces. Starting at the edge of the board, they have 2 or 3 traces, then a big fat trace, then 5 traces and a big fat trace. Maybe like a quarter of an inch wide, then another 5 or 6 traces, then another fat one. So there's 5 fat traces running to the edge of the board. Now about a little more than a quarter of an inch in from the edge of the board, in the middle of that fat trace is a big hole. Now that big hole is kind of a brilliant idea. The reason they did it was they allow you to easily connect an alligator clip to that hole. So on the cheap, with no fancy mechanical anything, you can just connect an alligator clip to it. So of the 20 pins, 5 of them go to these big round holes. And there's ground, there's 3-volt power into the board, and then there's 3 programmable pins. So if your project only uses 3 or fewer I/O pins, you could use those big holes. But instead of using alligator clips on this project, I didn't come up with this idea, but somebody else did a really brilliant thing. They made their custom circuit board that this board sits on top of, and then they put little 1/4-inch metal standoffs between the big hole in the microbit and the board below it, and put a screw on each side and screwed it together. So the standoff becomes the electrical connection to the board underneath it.
That's smart.
And I thought, the only downside is that the electrical connections are exposed. So as long as you don't toss a dime into the box and short 3 volts to ground, it works fine. So that's the approach I took, because the relay board for the link dipole, there's 2 AAA batteries in a carrier. So that's 3 volts in ground. And I needed 2 additional pins off the microcontroller, 1 to set the relay in one position and 1 to reset the relay into the other position. So I only need 4 of those 5 big connections: power, ground, relay on, relay off. So I used 4 standoffs. And the extra bonus was the way those holes are sequenced on the board. They go from like I/O pin 1, pin 2, pin 3, power, and ground. So I used pin 1 and pin 2, power and ground, and that left the third one unused. I didn't need it. And it's about, half an inch wide. And you could put a little piece of Velcro between those standoffs over the board and around the backside where the AAA batteries are. And you come back up and you can cinch down that piece of Velcro, and it'll hold the batteries tight in the battery case so they don't fall out.
That is
so
cool.
That was like, accidental, brilliant idea. So that's how the connections are made. If you needed more than 3 I/O pins and you wanted all of those little pins on the bottom, then you would use this big connector, and the big connector solders to a circuit board with a zillion pins, and then this microbit just plugs into it using the edge connector to make the contacts, and you get all 20 odd I/O pins then.
Cool.
So that's the long answer to your question.
George, and I'll make this as a postscript. Okay. mentioned buddy pole. It blew up, became a thing. You've got a very ingenious concept, and think about how to generalize it. You know what Step IR does to tune their antennas and all that, and it can mechanically fail. That's probably their biggest recall factor, is it mechanically fails. Okay, think about a multi-band Yagi. They're always a compromise. Is this a potential solution?
That's an interesting idea.
I mean, just a thought. I mean, I don't have the answer. I'm just throwing out something.
So the trickiest part to this whole idea is that the microcontroller needs power. And the easiest way to power it is with alkaline batteries, which eventually need to get replaced. So that's kind of the Achilles heel of this idea. And the reason it works for portable operation is you're never going to be set up for more than a day or two. And without doing any power management special coding on this processor, if you just popped in a pair of fresh AAA batteries and turned it on with the Bluetooth radio and everything just on, that thing will run like 24 hours before the batteries crap out. So for field day, it's fine. You put in a set of batteries, and when field day's over, you just throw them away. But for a permanent installation, you need to figure out some way to power it. And now you could always run just a tiny little, zip cord out to it or something like that. But I'd like to come up with a more elegant solution.
Sure. On the Yagi thing, keep in mind, you put power almost to the Yagi in something called a rotator.
Yeah, that's a good point.
Or convert the RF in the antenna to charge a battery.
Well, actually, that's a whole nother show, by the way. Energy harvesting is a big topic.
With all the Wi-Fi and cell phone signals in the air, George, that's how you're going to power it.
Yeah, you'd think.
Microcurrents.
So I know a guy who works for a company, and they're making an energy harvesting chip, and they're installing it in factories where there's mechanical motion, and there's some MEMS, like an accelerometer or some other stuff in this chip. And when the machinery vibrates, they're using that to generate enough energy to charge a battery. Can you believe that?
Wow.
I mean,
I think it's still a little ways away from production, but that's what they're trying to do.
Well, I mean, that's the same line of thinking that we have in modern hybrid vehicles, right? Like regenerative braking, things like that. Where are there things that there's energy dumped, either in waste mechanical or waste heat that could be reclaimed for some other purpose. But okay, look, I don't want to be rude. That is all well and fine, but we've talked about this project before, and you put something on Twitter this week that sent it wasn't the internet, but sent a lot of our fans of the show that interact on Twitter, tweeting.
Oh yeah. You mean
let's
the
talk about the
relay?
new thing.
The new thing, yeah. That link dipole thing. That's last week.
Yeah, well, last episode.
So the new project is a remotely controllable antenna switch. And the purpose for this thing, in our club, we do an annual event called our Antenna Shootout, and it happens every year, unless it doesn't. The last event we did was like 3 years ago, but it's supposed to happen every year. Anyway, so it's happening at the end of September, and we're going to take a bunch of portable HF antennas to the park, and we're going to do a scientific experiment to look at the relative performance between these antennas. And the way we're going to perform the test is I worked with Barrick K6BEZ on this idea. So he wrote some software that will control his transceiver, and it'll run one of the data modes, either Whisper or JT65. And when we first did this, he was running JT65, and at that time we did a 2-antenna test. So he programmed the software so that when we're testing antenna 1, it transmitted his call sign, and then after a couple of minutes, it would transmit on antenna 2 with my call sign, and then you can go to the net and see all the receiving stations around the world or the US that received your signal and what the signal strength was. So you can have a pretty good A/B comparison of the performance of the antenna. Same radio, different antenna on 2 time slots very close. So we're going to do the same thing, but this time we're going to do 4 antennas, And we needed a way to switch automatically between 4 antennas. So the first time we did this with 2 antennas, I had made a little coaxial relay control board, and his software would talk to my board, and it would tell the coax relay to switch to position A or B. So this time I redesigned this thing with the idea of doing 4 antennas. So there's a common that goes to the radio, and then there's 4 ports, 1 for each antenna, and the thing is software controlled from Barrick software. And it's just an ASCII control code sequence. You send it the string of ASCII characters. It turns on relay 1 or relay 2 or 3 or 4. So I designed the board in Eagle, made the boards, just got them this week, and that's what I posted on the Facebook page and said, guess what this thing is? And then I realized that silk screened on the board, it says something like remote antenna relay, and so a lot of people guessed it pretty quickly when they read the silk screen. So anyway, that's the basic board, and since I posted that, I've gotten a ton of recommendations and suggestions of features to add.
Yeah, actually, when I saw it, because I mean, the coaxial relay, the antenna relay concept is cool, but when I saw that, I was like, you know what? With a little bit of adaptation, that would be a good way to, if you have a single software-defined receiver that maybe you've invested a lot of money in, and you want to be able to do things like switch filters in and out, or to switch, converters in and out. I mean, that would be the basis for the start of a design that would allow you to do that.
So yes, you could use it for that. I actually have other controllers that would be even better for that because they're smaller and have more I/O. So if that's something that would be interesting too, then I might just make a general purpose controller board. Same concept, but instead of laying the thing out with coax connectors specifically to switch RF, we could just put small signal relays or digital open collector outputs and opto-isolated inputs and voltmeters and stuff like that on there.
We'll talk, because I mean one of the challenges, some of these things require basically 5-volt biasing. Like the SpyVerter, you can power via USB, or it can run off of a 5-volt bias voltage on the RF line. Mm-hmm. So another example would be Hans Summers has all of these little bandpass filter kits that are available for the Whisper project. But Smitty pointed out to me they're true bandpass filters. So if I wanted to, you could build all those filter kits, and then I could, in theory, build a box that goes in front of an AirSpy that, as I'm tuning HF bands, it would do the appropriate band filtering. Yes,
yeah, you could certainly do that, and yeah, so we should talk more about that idea. So one of the suggestions that someone came up with when they saw this thing and said, oh, it's a 4-to-1 antenna switch. What I really want is I want to switch 4 antennas to 4 radios and have a way to put my watt meter in the circuit to make it work. And you can actually make exactly that with 2 of these boards. So you can have one board that talks to 4 antennas and one board that talks to 4 radios, and the common, you just stick the watt meter in the middle on the common, and now you have a 4-to-1 and 1-to-4 switch.
Yeah, like an antenna radio multiplexer.
Yeah, and like in my station here, I only have one HF antenna, but I have multiple radios, and so I have a mechanical coax switch, but I got to reach around the desk and go fiddle for it and switch it. So I'm going to put one of these boards in the shack, and then I want to make a little control head. So your mute button idea, I got a chuckle when you said, oh, well, we can go beyond the mute button. We can make something fancier with knobs and buttons and things. That's exactly what I want to make too, which is a little control head with a microcontroller in it and a set of buttons. And you press a button and the microcontroller just sends an ASCII command to the controller. And the controller could be a power relay. It could be this coax relay. And I want to put that little control head right underneath my radio. So when I'm switching radios, I just reach forward at the front of the desk and press the button, and it'll switch the antenna relay remotely. Because on the antenna relay board, you can control it either through a UART or a USB connection, or with an XB data radio. And the beauty of that is you could put this relay control board on the other side of the house. So you don't even have to run 4 antennas worth of coax into the shack. You could just leave all those coax connections going to the board run one cable into the shack, and then remotely switch it. So there's lots of applications for something like this.
To take it a step further on the controller, you could actually even have the controller interface with your radios via CAT and, just be constantly sampling the radios, and whichever one had dynamic activity last would be the one that it could switch to.
Yeah, actually, you essentially build a band decoder function into this thing. I was thinking about that too, and there's a couple ways to do it. You can look at the serial interface, or some of the radios have band decoder electrical signals specific for that purpose, and read those voltages, and then auto switch the antenna. So in other words, let's say you've got an inverted V for 40 and you've got a Yagi for 10, 15, and 20, rather than switching the coax relay every time you go from 20 to 40, when your radio switches, the box would decode the fact that the radio switched and automatically switch the antenna. So this problem's been solved many times over, but why not do it again? I mean,
and cheaper.
Yeah, cheaper.
Yeah, more cheaper, actually, better, more faster.
Really, the more better thing here is the ability to remote it. And the thing that it really attracts me about using these data radios is you could either use your PC and write some software on it and have it talk to one of these data radios, or make a mechanical control head with a bunch of buttons and knobs, and you press a button and either the PC or the box sends the ASCII commands over the data radio. And you can have multiple different controllers around the house. You can have an antenna control device. You can have a different device that turns the power on to the shack. You can have a different device that turns your amplifier, in and out of the circuit or whatever, and control all that stuff wirelessly. And you just send different packets to the devices with different addresses, and it'll just work. I mean, we've built commercial versions of this kind of stuff before, and it's totally a doable problem. I mean, it's very easy to do. So I think that whole station automation thing is a direction that some of our build projects probably should take.
Well, cool.
Yeah, I'm really excited about it. In fact, I met with Barrick and John today at lunch and talked about it. And one of the things that Barrick said was, I like the idea of this remoting the coax relay.
But I can't work on it because I have to design version 2 of the antenna analyzer.
No, he didn't say that, although that would have been appropriate. He said, why don't you add a bias T? Funny you should mention that, Jeremy. He said, why don't you add a bias T? That way you don't have to power it with a separate line. You just put DC on the coax heading up to the remote antenna relay and decouple it at the controller end. And I said, that's an excellent idea. You tell me what value of L and C to put in there, and I'll put a bias T in it. And so I just need to get that info from him. But we'll probably stick that in there as well.
Awesome.
Yeah, boy, no end of projects. Huh?
No. But I mean, that's one of the nice things. Like we keep coming up with awesome ideas, and it's an interesting intersection because I mean, admittedly, as a ham, I have to do more listening right now than I can do talking. I mean, most of the talking I do, if I do it, is going to be through a hotspot using D-Star or DMR. But I have really enjoyed listening to stuff through the AirSpy, and RJ45 is a lot more, or Wi-Fi is a lot more efficient than running coax hundreds of feet. And I mean, that's effectively, Frank, you mentioned earlier there was a project of people trying to get like all these micro, remote RF sites. I know some of the guys at Tapper a couple of years ago at Dayton were talking about they have a goal of building these little low power receiver transmitter radios where, forget about ham radio being the big radio sitting on your desk, that it basically becomes like a grid resource that you just have nodes all over the country. And, based on what you want to do, you can get connected to the one that's, most likely to have a connection, and everything is IP radio. And, right. It makes it very easy and gives you a lot more capability. You just need people who have spaces that are willing to, put these things in and power them with flea power.
Things are changing. As they said in a famous movie, there is a great disturbance in the force. Whether that's to the light side or the dark side, who knows? But nevertheless,
I think
there's a lot of changes.
I think one of the changes, we might get a bill from the mouse now. Well, Frank, at this point, because we're going to ask you about your workbench too, but what's on your workbench is directly related to what we're going to be talking about this evening. So we're going to take a break, and when we come back, we'll find out what is on Frank's workbench and why you should care about it. Stay tuned.
Elecraft is a premier provider of high-performance transceivers, pan adapters, power amplifiers, antenna tuners, and many great station accessories. Elecraft products are great for DXers, contesters, portable operators, and anyone who wants innovative features and great performance. If you want to operate portable, check out the amazing KX2. It's my top pick for SOTA adventures. I've been a customer from the beginning, starting with my K2 transceiver that I built almost 20 years ago. Since then, I've owned just about every Elecraft transceiver they've made, and I've been a very happy customer. You'll really enjoy their products. Check them out at elecraft.com.
So welcome back. As I mentioned, Frank had originally reached out when we did our call for listener projects, and he started talking about some of the work that he was doing with accurate time sources in an effort to get really accurate frequency reference for both radio equipment as well as test equipment in his workbench. So Frank, let's start. Tell us what is on your workbench.
Well, one, it's a workbench. And I say that sort of in jest, Jeremy, because I've been building my workbench over the last, 10 months maybe. And that's how I came upon your podcast. And I had said, I've got to be a prototype listener, because that's what I'm doing, is building hopefully a good workbench and learning along the way what you need, why you need it, how to go get it in a way you can afford, et cetera, et cetera. So I'm building, a workbench, and I've got a coterie of oldies but goodies, but affordable, and some brand new things, et cetera, et cetera. And all of them, for the most part, I don't think my fluke meter needs an accurate time reference, but, all the sophisticated equipment seems to really need a good frequency reference, and we have to deal with time with that. So that's kind of my entree into it. And I will say to all the listeners, I'm not an expert. I'm learning, and I'll just share my little journey of learning on this with you.
Well, that's perfect, because we're not experts either. I myself, just kind of starting at the highest level as far as accurate time goes, there's something very comforting about the idea of trying to get time as accurate as possible. And what's really funny about it, if you think about almost any of our weights and measures, that a lot of these things, what we define it as a second is arbitrary to a certain extent. I mean, actually, I'll ask, do you know anything about the history of how we define what a second is?
I don't specifically. I am very familiar, with measurement in science. But go ahead. How did we get to a second?
Oh, I have no idea. But it's one of those things. Like when they look at what a kilogram is, there's actually a really interesting story about the standard of a kilogram, and that they made 6 of these things as standards and shipped them off to different parts of the world. And then after many hundreds of years or whatever, they found that the mass of these things had actually just changed because of the materials they were made out of. And so, I mean, just understanding weights and measures and references to things we take for granted, like a kilometer or a foot or an inch or any unit of measure, there's always a good story behind why it is what it is. But, everybody's familiar with time, right? Our entire lives run on it. And folks have clocks of varying degrees. Almost everybody who has a PC has a PC that is synchronized with a time server on the internet. But, you talk about wanting to have an accurate frequency reference. What is the correlation between time and an accurate frequency reference?
Okay, let me digress very briefly and get into that. In science, when you go read some of the moldy oldies like Lord Kelvin and many of those who talked about this, is that you realize that almost all measurement is relative with the appearance of being absolute. And that's a fundamentally important concept, because we're all searching for the holy grail of something that's absolute, but we get there through measurements that are relative. Okay, King George, I think it was, his foot was the original concept for a foot. Gee, how hokey could that be? Just look at a shoe store. We got all kinds of feet, right? But how do we get, to frequency on the basis of time? Well, frequency might be thought of, as a change for a period of time. Simple concept, carried out lots of different ways. It's often said that the person who has a watch knows what time it is. The person who has two watches is never sure, because they're both relative and they're never exactly the same, but yet we want the appearance of something absolute. An old wooden ruler made out of cheap balsa wood in the heat of the summer down here in the South, as I might say, it's actually far less accurate than that same ruler in your neck of the woods where you don't have the humidity, because that wood expands when it soaks up moisture. Yet the markings on it want to give the appearance of being an absolute measurement, but it in fact is relative. So, there's a great, there's a famous book called The Road Not Taken. It's about one of these self-help books about 20 years ago. Well, there's two roads. One is to become, in a term of affection, a time nut, where the study of time and measuring time is in itself what you're studying. The other one is understanding the time nut world well enough to get a good frequency reference. For example, why does so much bench test equipment use 10 megahertz as the frequency standard?
That's a really good question, because test equipment being one thing, but you're right. A lot of these things actually have like a little BNC jack on the back that will say 10 megahertz input. Oscilloscopes, spectrum analyzers, and actually even in the professional audio world, you can buy standalone time sources that you would use to feed those inputs so that you're synchronizing multiple pieces of equipment together. And it's almost always a 10 megahertz reference. Why is that?
Well, I don't know the complete answer, but I can give you a pretty good story that's more or less accurate. Someone at Hewlett Packard probably decided, hey, 10 megahertz fits into the range that this piece of test equipment is supposed to operate and measure, and so when you design other circuits around it, 10 megahertz becomes a sweet spot. Well, that's not so sweet when you have a signal generator like I have, the venerable HP 8640. It uses 5 megahertz. Why? I really don't know. But you look back at equipment and look at those jacks you're talking about and say, as we go to older equipment, not all of those use 10 megahertz. Well, you think about the evolution of equipment, the frequency range that older equipment might deal with, like that signal generator, which a lot of the people who do a lot of RF work, they swear by that. That is the kind of gold standard. It is rock solid. It has the least amount, of drift after you warm it up, and it's kind of that beloved piece of equipment, which is why I bought it. I have a very good friend, Tom Brown, who's an RF engineer. In fact, everyone knows who George Thomas is of Amateur Logic TV and Ham Nation. Well, George Thomas replaced Tom Brown as the RF engineer at a radio station here in Jackson, WJDX, the 50,000 watt clear channel one. And so Tom Brown is a good friend of mine. We go to church together, and we kind of do ham radio stuff together. And Tom is an expert on oscilloscopes. He has over 50. Now, that's what he tells his wife. He has an air-conditioned storage unit where he has another 30. So I don't think his wife listens to this podcast, so I feel comfortable in telling you that. Not only does Tom know every Tektronix oscilloscope and many of their spec analyzers and other things, he knew the engineer who designed it. So he's a good resource for me to have. So I'm learning. He's one of my test equipment Elmers. So when you go back and you kind of look at the history of certain classes of test equipment, you'll see that frequency reference changed. So I'm kind of making an inference here that's a relative point, that's a sweet spot for the circuit design, that if you get that reference signal in, then it works well for that piece of equipment. But keep in mind, we often don't use just a signal generator. We often have a counter over here to count something that the device under test, we're doing something to it, tuning it, whatever, calibrating it. So we need a generator signal. We need to measure a signal, perhaps as it's been altered by the device under test, and so on and so on. So remember that thing about the guy with 2 watches is never sure of what time? Well, it doesn't absolutely matter. Now, the time nuts would just say, this guy's, doesn't know what he's talking about. But from a scientific, philosophical point of view, get that thing as accurate as you can. But what's more important is that each piece of your test equipment has the same error, if you will. If it's off, then you want to be off by the same amount. That's why no 2 watches are going to read the same. So if you have 1 watch, you're certain. If you have 2 watches, you're never certain. So in that same logic, Jeremy, one of the things that's good to do is to daisy chain that same frequency reference to all of your test equipment that you're going to use. And hopefully your input frequency reference is as accurate as you can afford to make it be. So that's kind of a song and dance around your question. I'm sure somebody from the time nut world, like Mark Sims or some of the other folks there and you can kind of Google time nuts and you'll get about half a dozen very, very good websites. They'll get into a more elegant but esoteric discussion for someone whose main focus is how do I get the most accurate results from my Workbench test equipment. And that's the road that I've kind of gone down. So there's a relationship between frequency and time because we generate a frequency based upon timing. And so I guess that's kind of the fundamental way of doing that. Now, your next question, I'm sure, is going to be, okay, what are the different approaches to get that signal? Is that a fair guess?
It is, but before we go on, I mean, one of the things, you were talking specifically test equipment, or even in my former life, when you had a lot of digital audio processing, when you're passing digital data back and forth, having those machines have the same clock reference were important, for signal integrity. I mean, honestly, a great example, you may or may not know that I have a YouTube channel, which honestly I haven't done much with it in a while, but, when I would shoot long videos, I'm recording audio off camera on a separate device. That separate device has its own oscillator inside for the clock used for the analog to digital converters. The camera has a separate clock in it. And when you go to actually put the audio recorded off camera together with video, you have to do some work to synchronize those things. And, specifically for long files, about every 5 minutes, you have to resynchronize them, depending on your sample rates. In your radio, there's an oscillator in your radio that at the end of the day, like you said, there's an input signal. And for most radio architectures, there's some type of a local oscillator inside. And then there's the frequency counter telling you what frequency you're tuned to. And those both share the same reference time unit inside of whatever that oscillator is.
So in principle, you want the appearance of absolute measurement, but it has to have the same relativity for sure. And that same relativity is the concept we're talking about. I do a little shade tree work with video for ham clubs and for my church. And if you take the audio track, if you mic somebody up and you're interviewing them, in some sort of crowd, you're going to get all that background noise. Well, as you well know, probably better than I, you may take that audio out and clean it up through some DSP software, capture the noise in the background, then go ahead and, pull those frequencies out and things. And then you put that back into with the match to match the video. Well, there's nothing, more embarrassing than have the lips moving, but the words aren't exactly going. Yeah. And then you get into music. And so I hear you. And so that is important. That's why I kind of harp a little bit on this business, the appearance of absoluteness. But the most important thing is the same relativity to that. And that's that's kind of the approaches. Let me throw some approaches out. I think we've all listened to WWV. I had the opportunity. I used to be a GS-15 for the Department of Agriculture and managed a program for them part-time, and I would fly up to D.C. about 1 week a month, and I did this for several years. And while I was in D.C., I would stay at a contract hotel, and I would go to the waterfront center and do my work, and then I'd go to the hotel and do what people who are stuck in hotels do. You find other things to do, and so I got a chance to go visit the official time, and the Navy maintained this, and was 2 Hewlett-Packard mini computers operated in sync with one another. And so that was, in fact, the official time. Now, was it accurate? Fairly. But I had the person explain that business. So we give the appearance of absoluteness as best we can, but everybody needs the same relativity. So I didn't create that comparison, Jeremy. I kind of got that from the guy who ran that computer system for our official time. And that gets fed out at the time to Colorado, to WWV, and then that got fed out. Well, as the GPS world evolved, I happened to have been involved in a project. It was a large project, a $60 million project that I coordinated with NASA and the state of Mississippi on remote sensing. Well, remote sensing got important because GPS got important, and we could geo-rectify and geocode pictures from planes and space. And that began to filter into this. And so the timing from the GPS satellites became the practical official time. The reason for that is, what if the clock tower in the middle of town in Back to the Future, nobody paid attention to it? But yet it was the official time. Mm-hmm. You get what I'm driving at?
Oh, absolutely. It's like, it's not as regular, but in this area we have tornado sirens, and at 1200 hours Eastern time on the first Wednesday of every month, they all go off at the exact same time. And like you said, that's the illusion of absoluteness, because they're all synchronized to the same source.
And, before the GPS satellite business evolved, what kind of sources could we have here on terrestrial Earth? Well, we know a bit about the decay of materials. You kind of alluded to that earlier. And cesium has some characteristics that those who know much more about it than I do, in the nuclear physicists know that you can take cesium and you can build a device that will have a timing principle around a frequency decay that's pretty regular. Well, so a cesium atomic clock was the thing. Well, it's expensive. Well, rubidium is a not quite as accurate, but a lot more affordable basis for a timing device. And so when you get into what we're focusing here on the podcast, is that a rubidium standard, which has a little heater in it, plug it in, give it electricity, it'll generate some heat, like a lot of other things will. And so a rubidium standard is something that you can buy on eBay and on other, for sale sites. They're usually pulled from, some other place, and you're buying them cheaper. You wonder if they work. There's some ways to test them. And so a rubidium standard has been, for a number of years, the standard that you would have in a lab. And so you'd have a nice rubidium frequency standard, and that got piped out to all the test equipment. Remember, absoluteness in the rubidium device, but relative in that it didn't matter if that rubidium device was off a little bit in its absoluteness, but every piece of test equipment had to have the same signal. So that was a thing, and it still is. And that's probably the way to go. And to maintain a rubidium standard, you need to keep it plugged in, and heat is our friend there. That's the opposite of what we usually do. Put a fan on it, put a piece of metal on it so it'll soak it up. And so we kind of want that heat for the rubidium, and we want to keep that heat as stable as possible. You were about to ask something.
Yeah, well, I was about to talk about the actual output a little bit, but I mean, you've touched on something else, right? So most people who have modern radios are familiar. Again, all of our radios have oscillators in them. And modern technology, because these rubidium standards, I mean, they're basically a box, right? I mean,
exactly.
On average, how big are these things?
Well, they can vary, but about say half the size of an iPad, but about an inch thick.
Mm-hmm.
I mean, and again, that'll vary, but that gives you an idea.
Now, inside our radios, though, there have been, especially in the early days of radio, oscillators were created through many different, means. And, especially in that like late 80s through the 90s, early 2000s, one of the upgrades that was available for a lot of ham radios, and I'm thinking specifically if you think of like a Yaesu 897, 857, 817, you could actually pay for an upgraded oscillator that was what we all know as the TCXO, or the temperature controlled oscillator.
And that builds upon the crystal oscillator of yore. What happened to the crystal? Well, temperature variations were not its friend. So how do we control temperature? Well, one of the ways of doing it is a constant heat, a controlled heat. And so that was kind of a next generation for the TXCO. I have an 857 in my Go box, in a Gator box, and so I'm very familiar, with that. And just for reference to our audience, why is the TXCO a lot more important for digital data than for single sideband?
Well, it's because you're working with a lot narrower bandwidth. That if you're working with something that's only much smaller than kilohertz wide signals, especially with these modes like JT65 or Whisper that really require very precise, bandwidth and band spacing. If you're off a little bit, they don't even work.
Exactly. And so when timing becomes important, that then, becomes something that is more critical, even, if you will, in our radios, and certainly on our bench test equipment. So a TXCO was kind of a next-gen way of looking at a more stable frequency reference, whatever the frequency that crystal or whatever the device is designed to put out. A rubidium standard is often at 10 megahertz. Why? Nothing inherent about the rubidium. They're just mimicking a lot of the test equipment and what they need for an input signal.
Now, when we talk about that signal, going back to the rubidium source, I mean, and the reason I asked about the size, right? The average, the TCXOs, they're these days in individual components the size of your pinky, your pinky fingernail. I mean, they're tiny, and then we get into these larger units like the rubidium source and some other things we're going to talk about in a minute. They usually have a BNC jack on the back, correct?
Right.
And then, so what is the signal that actually comes out? Is it a sine wave, a square wave? How big is the amplitude?
Which one do you want? Because depending on the design, it can put out a pulse, it can put out a sine, it can put out a square. The one I have puts out all three. So for different uses of that, you might want one for this, one for that. Okay. Now, let's go back, and I want to throw in something. Most folks have probably discovered Dave Jones down in Aussie land, down in Australia, in his EEV blog. There are some really neat videos in Dave's own inimitable and irreverent way where he breaks down some of these standards. And, he gets people just send him all kind of stuff, and he tears it apart. That's kind of his stock in trade. And so if you want to go see the sizes of some of these things, and I think he's got one on a cesium standard, if I remember, and it's kind of a big box. It might need a little bit of a forklift to move, if I'm remembering that correctly. But a rubidium is a much smaller, smaller than a lunchbox type of thing. And he breaks some of those down and goes through and really kind of explains in a nice way how the circuit works and what they put out and how they put it out. So for some applications, you might want one pulse per second. For another one, you might need a sine wave. And for another one, you might need a square wave. I have a couple of oscilloscopes. I have the venerable Tech 2213, and then I have a newer Regal, the 1054Z, 4-channel versus the 2-channel. And, I'll often put the GPS discipline oscillator, which we'll introduce in just one moment, on there just to monitor. And I've been monitoring mine now for about 3 months. I mean, I've just had it running. I've been wanting to make sure that it's stable, that it works, and we're going to get into that. But I'll take the output for a pulse, for a sine, and for a square, just to look at it. Why? Because we like doing that, right? we want to make sure we know the waveform
exactly. Yep.
Of the signal. Now, in terms of the dB out, off the top of my head, I can't tell you. I've measured it, but I can't really tell you. So at this point, we're on a TXCO. Well, those work and they do well, but you get that Yaesu 857D out in really cold weather, really hot weather, really damp weather, et cetera, and it's going to impact that. So what do we do to make that better? Another approach is using a disciplined oscillator. That is, it's on its own. It's going to run in infinitum, and it's going to do what it's going to do. And it will drift. And that's one of the big problems that you have to look at when you're buying a pulled or used rubidium standard, is whether or not it's been checked and how it's been working, and has it been calibrated or measured against a really good relative standard. So a GPS discipline oscillator has a neat idea. It says, okay, we can get what appears to be an absolute timing standard. It's relative, of course, but it's the relative one that so many people use because it's the timing that comes off of the satellite. And just remember, it doesn't matter what time it really is. It's what time we all agree that it is, because that's what a standard is. Fundamentally, it's an agreed upon way of determining a weight or measure. So if we take a GPS device, get a nice little antenna that will get several GPS satellites up there, and measure that and put it in a circuit that will say, where's that oscillator at right now? Okay, if it's getting out there now, it's getting on the edge. Let's then take some heat and heat it up a little bit, and then that'll bring it back down. Or it's getting too low. Well, maybe we'll turn the heat off. I may have that backwards, but the point is the same. So this GPS disciplined oscillator is less expensive than a rubidium standard, and it's one that is continuously calibrated, but it's calibrated against that relative external standard of GPS time. And as you alluded to before, that's what our computer networks run on, and so on and so on. And we could tune in WWV, and we could kind of set our watch by it, and we've all done that. And it's kind of cool if you're a shortwave listener, if you're at a cocktail party and someone says, "Oh, my Rolex says it's whatever," and you go, "It's about 4 seconds off." How do you know? Well, because I listen to WWV, and by George, that is the official time. I don't care what Rolex says. So again, you got to keep in mind, we all do that, and it's our agreement that makes the standard. So that GPS discipline oscillator, and I put my hand on it, and it'll get hot, and it'll not be so hot, and I've got an infrared thermometer, and I'll put the little red dot on it, and I'll measure it, and all that's fun, and it helps me learn a little bit about it. So I wound up getting, I didn't spring for a rubidium standard, but there are a number who do, and more power to them, and I may get one day. But what I got was a GPS discipline oscillator from a eBay company from China. There are a number of companies that will take pulled GPS receivers out of usually the cell phone companies or a number of others. Because, cell phone companies, just to get your bill accurate, they got to know kind of when and where you made a phone call. And back when we were charging for time, how many minutes did you use? And we still do that for many plans. So it's important to cell companies. Another good friend, happened to go to church with Thomas, N5WDG. He is the regional RF design engineer for about 4 states for a 3-letter cell phone company who also has satellite TV. And that ought to narrow it down pretty well. And so in dealing with Thomas, I know a lot of what they put in the towers and how what equipment they use, and they use Symmetricon, as a GPS discipline oscillator system for their timing and so on. So I opted for a $130 device from a seller whose name is ANON or AMOG 1010, AMOG 1010. He's got a 99.3% positive feedback, and he certainly got one from me. And I paid about $130. And in this one, there is a Trimble GPS box that was pulled, I'm sure, from a GPS device, that got tossed away, sold because they upgraded or whatever, however those things are recycled. And it is a design that if you get into this, you'll see that there are several classes. And by classes, I don't mean better than the other, but they're just different. And it's like Garmin versus other GP. They do the same thing, but they have a little different standards. And what I have is called a UCCM receiver. And that's only important because that puts out certain data in a certain way. ICOM may do it one way, Yaesu may do it one way, Kenwood may do it another way, and somebody else may do it a third way. But you just have to know that, because what you're trying to do will come out the same. So this is a UCCM GPS discipline oscillator. It is built into a very standard aluminum project box that you can screw it down to something. It does get warm. But it's doing pretty well. How do we know how well it's doing, you ask? Well, we actually have some measurements for what kind of deviation does your device have over time. The drift, what kind of jitter does it have, and that sort of thing. And someone named Allen, last name Allan, came up with a type of standard deviation. I've taught statistics for 40 years and edited a journal on spatial statistics. So standard deviation is just like a socket wrench to a mechanic. It's just one of those tools you always use. So it's a measure of fluctuation of data, in this case, over time. And so the Allen deviation is kind of the statistic to measure that drift based upon that jitter over time in a GPS discipline oscillator. Well, how do you measure that? What we kind of sort of want to do, if we're not a time nut, we just want a good frequency out. Well, like a motor or anything else, you need to check the oil every now and then. If it's making a funny noise, you got to see what's causing it. Well, by analogy, you ought to check a GPS discipline oscillator periodically. You and I are the type, we want to check it all the time. So I actually have on my Workbench computer, an older Dell that I've beefed up to 16 gigs of RAM and so on and so on. I have 2 displays on my Workbench. I have friends that, why would you need a computer display on your Workbench? I said, well, when you get up over about 100 reference documents, you sort of want to keep them in PDF and not have the room for all the paper ones. So Absolutely. I know I'm going to be looking up stuff, right? I know I'm going to be looking at your podcast or Dave Jones or any number of YouTube videos on how to build something. And so you're going to want one screen, so you just have information. Well, I've got another screen that I do remote control of some of my equipment, like the Regal oscilloscope. It's got computer control on it, and I'll put in that other screen, my oscilloscope while I'm doing some other work. But I also keep while I'm testing this GPS DO, I keep a piece of software called Lady Heather. It's free. Mark Sims wrote it and keeps it up. And it connects through a serial port on the GPS DO to the computer, and it will read that port, and you kind of tell it it's a UCCM device, or it'll read it and tell you what it found, either way. And it displays things that you can tell it what you want to display. So you can roll your own display of the parameters of that GPS DO, and it's quite cool. And did I mention it's free? And
we like that. As hams, we love that.
And so there are other competitive pieces of software that are not free, some quite expensive, and there are people, good folk that they may be, they make a decent living out of doing that for sale commercial software. But Mark Sims has Lady Heather out, and it's in version 5, and he's got another version coming out. And if you subscribe to the Time Nuts listserv, you can read all you ever want to know, and you will learn. I mean, you may not be interested when you start reading it, but you will learn. It's like reading the mail on the ham bands. You can learn a lot by just listening. And so I will have that running. I use TeamViewer for my remote access. And so sometimes before, lights out, bedtime, I'll say, what are you looking at on your iPad? And I'll say, well, it's my Workbench computer out in the garage. I'm just checking how my GPS DO is doing. A little bit, like a pet, like a dog you need to check on them, and you need to take them out sometimes. You need to check on your GPS DO periodically, because remember, I'm kind of sort of burning this in to make sure this one is working. And it seems to be. So what I will then do...
Well, let me interrupt if I may. So you talk about burning in, which, of course, we've talked about there are heaters involved. And one of the things, and I don't know much about this, but I know that the longer you let them run, the more... and I don't know if it's precise or accurate, the more settled they get, the more predictable they are.
Correct. And so I mentioned earlier, heat is our friend here. And it does get warm. So what I've got to do is to decide, okay, how do I want to package this? I now have a very inexpensive PC-Tel GPS antenna. I paid, I think, $32 for it on eBay. Now, it came with a little patch GPS antenna, a little magnet on it, and I have an IT rack for a lot of my equipment, and I just stuck it on top of that metal rack, and, click, it's there, it's not moving. And for a month or so, I just used that patch antenna, and I didn't get all the birds up there, but I got enough of them to get a pretty good signal. So I now have this little cone-looking GPS antenna, and I have to decide where to put it. I'm probably going to mount it in my attic, which will be just above where my workbench is. And I'll get it up at a peak, and I'll do a little testing here to see how much open sky I can get. I'm in an HOA. I can't really get away with mounting it outside, although they have no problem with me mounting a little device that will tell my irrigation system if it rained yesterday. I mean, that's okay, but GPS antenna, wow, we're really getting wild here. So I'll put it up in my attic. I'm fortunate enough to build this house. I have a very large attic. I mean, I have about 17 foot of headspace in my attic.
Wow.
And so that's where my antennas are. So I will get up, and I actually have one of those goofy ladders that you can, make them do everything from being a platform to, a ladder and all that. I keep one in my attic because I'm always climbing up and down, fooling with antennas or changing something. So I'll just go up and I'll mount it, and I'll run the cable. And I want to use a good low-loss cable, and I'll run it down into my workbench. But what do I do with a GPS receiver? Well, I may mount it on a piece of copper just to kind of be a little heat sink. But then how do I get that signal out to my equipment? That's another related thing. And in the show notes, there'll be a piece of equipment that I picked up fairly cheaply. And if you think about what video signals, what frequency range they run on, there are many fairly inexpensive and used video distribution amps. They'll carry 10 megahertz with ease. There are some YouTube videos of projects. If you'll Google GPS DOs and distribution system, you'll find, and I apologize, Jeremy, it's Jerry with Gerry, and his last name I'm blocking. He's in the United Kingdom. And Jerry Sweeney, Sweeny. He has a wonderful set of YouTube videos about his taking a video distribution amp to use a GPS DO, as well as his rubidium standard that he has to feed all of his bench equipment. Very, very good stuff. He does a very good job and is very elegant and very nice about sharing his circuit boards and all this. So I got one made by Six, the company SIX, 6 output video distribution amp from Sigma Electronics, and it's model VD-100A. I don't think there's anything very particularly cool about that. It fit my price point of cheap, but seemed to work and that sort of thing. So I have that little box. So I've got to do is put together some sort of packaging to put this GPS DO system, and then how I'm going to feed it. And I mentioned I have a vertical IT rack on rollers, and so I'll mount that either on the top of that rack by putting some extenders, or I'll mount it on some shelves behind that rack and then just do a coax feed to it. But that's the basic system that I have. And I want to feed all of my signal generators, frequency counters, spec analyzer. And there's another machine I want to feed, and I want to talk about that in just a moment, because there's another device out there in the wild that was built for an entirely different purpose, but it's very important for measuring frequency. And I'll get to that in a second.
Well, let me if I may, because one of the things that we've kind of taken for granted here, let's talk about the GPS part of GPS Discipline Oscillator, because, I mean, all of us are familiar, especially at this point with our modern smartphones, all of us are familiar with the fact that, okay, there are a number of satellites, orbiting the Earth in geosynchronous orbits. That there was the original GPS system, and then from the Eastern Bloc countries, we have GLONASS, which offered a little bit more accuracy for positioning than traditional GPS did. Just real quickly, can you give a high-level overview of how, we talk about having a position lock, and you mentioned earlier about being able to see X number of birds. Just at a very high level, can you talk about how, the position lock happens?
Okay. Let me do a little quick history, because it's very important. If we go back to the early 90s and someone had a GPS device and it was like, ooh, wow, you got a GPS device. Now, it was not very accurate. If you went to Walmart and you bought one of the early Garmin's and you took it, say, fishing with you, and you were going to sort of get the location of that sweet spot where you caught that 12-pound bass, or you were hunting and you wanted to go, to some location and you track where deer or other animals that you wanted to murder with a gun or whatever you're doing with the GPS device, you may not get back to that spot in the lake. And you probably wouldn't get a signal under those leaves if you were in the woods. Now, why not? Well, what were GPS devices used for and who owned them?
Well, the military, of course.
And for public use, they intentionally entered some distortion. So you got a sort of good signal, but not nearly as good as the military got. Now, under President Clinton, he signed the executive order, and I think the military kind of agreed because, they had kind of moved on and it didn't need to be protected. When he took away that intentional error, that's what made consumer GPS devices shine. Suddenly, you went to what's called double differential accuracy. And let me give you a rough, my background's remote sensing and GIS. I've been doing that since the early 80s and taught it for a number of years. So double differential will give you just a rough, without getting into the mathematics of it. You could find your neighborhood with that arrow in it. You could find your front door with the arrow taken off.
Mm-hmm.
Okay. So that was a boon, okay. Now, why then did Garmin and Trimble start making so many consumer GPS devices? Because that accuracy for the device they were selling got double differential accuracy, which at the time was what that guy for the Department of Transportation who was surveying that new off-ramp on the road was using. And that one was $25,000, and yours was $350 at the time.
Mm-hmm.
Okay. So that's a little bit of the history of that. Okay. Now, one of the quick things that you would tell someone who's trying to understand what would be the technical version of Google Maps, that is GIS rendition, you need 3 GPS signals to get latitude and longitude, and then the other dimension, which is verticality, the Z dimension. You might know where the tower is for a repeater, and that's important. But the third thing you really need to know is how high the antenna is. So you need to get the vertical measurement fairly accurate as well. And so you got to have at least 3 birds to mathematically figure out those points. And 4 gets you a little better reading on that vertical element. So
I mean that's literally triangulation, right? But like reverse triangulation?
Of a sort, yes, of a sort. But remember, some of those birds are in stationary orbit. So if you looked up, you'd look up in the same relative place at the exact same time, and somewhere up there, that bird ought to be there. At that. It's same thing with DirecTV and Dish and others. Why they have to turn that dish to get their satellites is they have to get an optimal signal, just like we would do with our ultra high frequency, let's just say HSMM mesh or whatever, we're doing with that technology. You want to lock in the maximum signal, just like the old days when you had an old Yagi TV antenna. You'd turn it toward, this station, and you'd turn it toward the other station. I had a brother 5 years older than me, and he would wail on me if I didn't go out and turn the antenna so he could watch the team he wanted to watch on Sunday afternoon for NFL football. I learned that lesson very early in life. Yeah. But it's the same principle. We use it every day when we have any kind of directional antenna. We just have, a bigger phenomenon, if you will, to do it. Now, we're also taking the other direction and going into the earth with ground penetrating radar. Archaeologists are finding really cool stuff because those people that wanted to find minerals and oil pioneered that and paid for it. So we're now benefiting from the ground penetrating radar. But the point is, the more birds, the more stable, the more accurate signal you get to start with, and then the more stable signal that you have over time. So you want to get enough of those GPS satellite signals to hit your antenna so your GPS DO will not have as much jitter. Your ADEV will be smaller over time. That is, the relative error in that signal you want to feed your test equipment will be about the same. But you do want it to be as tight around, that frequency as possible. But let's face it, how tall are you?
6'1".
You're not.
I'm not.
You're not.
Oh.
And no answer is correct because you vary by how much water you had, whether you got rid of some of that water lately, and so on and so on. So I'm saying that not to be rude, but to simply bring it back to remember, we want the appearance of absoluteness, but relatively 6'1" is good enough for me. Gotcha. I know about how tall you are. So how accurate do you need to be? That's where I'm going to. And so what I think people will face is how accurate are you willing to pay for your bench equipment to be? If you got enough money you want to spend, you can have it be very, very accurate. But how accurate do you really need it to be for the circuit design and testing that you're using? And that's not to say it doesn't matter. It does matter. But just like when you said 6'1" and I said you're not, I know in principle you're not. Okay. Because as we go down and would measure you exactly at a given time, we could get a more and more accurate number. But how accurate does your number need to be? Well, mine right now has 7 zeros after the 10. That's how accurate my frequency of 10 megahertz is. Is it 10 megahertz? No. But darn near it. I mean, so how accurate? That's another question based upon what you were asking about the number of birds and number of satellites. And so right now on 2 different frequency counters, bearing in mind they're not perfectly calibrated either, but it's that number of zeros away from being exactly 10. So how accurate do I need it to be if I'm winding a toroid to build a set of bandpass filters, which I'll be doing in about 2 weeks, from 160 down to 10. And, one of the things on my workbench is I'm taking an old QST article and I'm just building them to get that experience as you and George kind of bantered back and forth with your Arduino mute button. As you go through it, you get the aha, wow, I can do this. And so I'm building some of those to use, and I'll use them probably at field day and a couple of other times. But, by walking through that, how accurate do I need to have the cube that I measured for that circuit? And that's always a question you should at least, how accurate is good enough? Well, I rambled on about that, but.
Well, I'll tie that back to something that it's a concept that I had never thought about before, but George really did a great job, especially in the early episodes about, when folks start being interested in picking up test equipment, half of what we do in amateur radio doesn't need precision or accuracy. It needs indication.
Mm-hmm. Right.
And again, by using these types of frequency references, you're immediately showing a desire to be as close as possible and or as close as is non-bankruptable
Right. Exactly.
And at the end of the day, the point that you keep driving home is by having a common reference, then all of your equipment at least is going to have the same context of error across all of them.
And if you can get the absolute amount of that error, and I use that with a lowercase a, it's not absolute, just like you're not 6'1" exactly, and I'm not 6 feet exactly. And as the older I get, I shrink. I mean, that's the way it goes.
Yeah.
But if that accuracy is in the ballpark of good enough in practical terms, then it's the same relative error, which itself is fairly small, and that's the sweet spot. And so what I've done, I'm like the next person. I try to get the most for my money, and then sometimes I will. Someone gave me an SDR receiver to review and said, keep it. You did, appreciate your feedback. Well, I had several and said, I don't need that anymore. So I sold it and I bought a vector network analyzer device, and by the one by Tom Bayer over in the United Kingdom, an SDR kit, and it's a dual port device, and it will do a lot of really neat Smith charts. I've been working with the Italian company that's come out with the 3D Smith chart software, and I'm trying to get those two companies together so his software will read the VNA, directly, and that sort of thing. So I'm trying to learn with that. Well, when you're learning, you almost need more accurate numbers than just as a crutch, mentally, than someone perhaps like you or perhaps George. Yeah, that's good enough. I mean, but when to say that's good enough. And if you're learning, you're always afraid that you're missing something. So, there is a concern about accuracy. So with that VNA, I bought a Leo Bodnar GPS discipline oscillator as well. And it works very well with this particular vector network analyzer. And so I have not cranked up the Leo Bodnar, just, time is nature's way of keeping everything from happening at once, and it certainly works on my Workbench. And so I will get the Leo Bodnar out. It comes with a patch antenna, and I'll run that for a little while as I learn the VNA. And then I'll probably add the Bodnar to get a feed from my PC-Tel antenna that I will mount soon up in my attic. So you got to think about a system for deployment of those reference signals and that sort of thing. And when I get the frequency thing down, hey, I'm going to look at a standard reference for a voltage and current.
Well, let me ask a couple questions. First of all, this network analyzer kit, because I think that might be interesting for folks. Do you remember where it's available from?
SDR-kits.com.
Okay, so it looks like this is the VNWA3, maybe?
Yes, 3E. I got the extended board, and it's not cheap. It's about $535, but I sold a piece of equipment to be able to finance that. But it's like anything else. I figured I would need the S parameters for tuning, filters and maybe tuning cans for repeaters and, those kind of things. And so I said, hey, that's something I want to get. And, from my vantage point, I've kind of analyzed what's out there and all this and read the reviews like the next person would. And I decided to bite the bullet to get that. But it brings up another point. A lot of these devices need a good reference signal.
They do. And you mentioned the Leo Bodnar unit, which, so oddly enough, and I want to talk a little bit more about specific equipment here in a second, because, we mentioned the Trimble earlier. But so Leo Bodnar is a gentleman from the UK who actually, as I was researching him, he's also very well known in the, I guess we'll call it computer simulation control, in the sense that he builds a lot of really nice car simulation and aircraft simulation, interface devices for computers like gear shifts and steering wheels and pedals. But he also has developed this GPSDO that's unique from a lot of the other ones that you're going to find on eBay because it is a variable GPSDO. You can
from 450 hertz to 800 megahertz.
Yes, and he sells two versions of it. There's a really precise version and then a really, really precise version. Right. Actually, this is a device that is available for sale from our friends airspy.us. They started carrying...
Yes, I noticed that.
Yep, so they carry the regular one. And then on top of that, and the other thing that's cool about that one has two outputs that you can customize the shape of the waveform, the frequency of the waveform, and the amplitude of the waveform. And then based on what you set the first waveform, it influences what you can set for the second. But if you wanted two separate 10 megahertz outputs or two separate 100 megahertz outputs.
Or in my case, I need a 10 and a 5 for my HP 8640.
And the other thing that's cool about it is if you're using the same frequency on both outputs, he gives you the software that you can adjust the phase of the two signals if you needed to be able to, put the two signals, say 90 or 180 degrees out of phase for whatever reason. And it's, I think they're about $220.
I don't have written down what I paid for it, but that sounds about right. I mean, I ordered it from SDR Kits. Mm-hmm. Because it was kind of the recommended companion one, and the phase stuff with the VNA, that kind of went together, which is why they sell it. And and he also has an NTP box that
I was
I've heard
about
you
to
mention.
say, that Leo NTP server, it basically has the same oscillator. Design in it, but it is designed specifically as a local network time protocol server for your network. It has an Ethernet jack and one BNC out, and it has a little OLED display on it. And, he basically has implemented in hardware on the microcontroller in that box, the NTP protocol. And there's a video on YouTube, because he has one of these on the internet that anybody could connect to use as their time source. And he has one on the internet where he's showing that there are literally, thousands of time requests per second, and the thing's just not slowing down. And again, that goes back to my interest in having a super accurate clock in the house, even though I have no real need for it. But it's pretty cool. But one of the questions I was going to ask, so with this vector network analyzer kit, you went for the Leo Bodnar, even though you already had a Trimble-based unit. Why is that?
Well, for some of this is intuitive rather than logical. And the intuition was Tom Bayer designed this, they're selling this, they recommend the Bodnar. Because for some of the tests, you may need to adjust that reference frequency or adjust the phasing for some of the tests. And without, kind of nailing that down to the nth degree, Jeremy, I said, okay, if they're recommending it, and that's what a lot of their examples are. They have a really cool book that they sell to go with that VNA, by the way. I was very impressed with it. I went with that in addition. So it was kind of a splurge, even though I had the other one. I figured the VNA would be different enough that I would just go ahead and get that to work with it. Plus, I might take that out in the field because it's a very small box.
Yeah, it's tiny, and I think the voltage input on it is you could either run it off USB, and then I think it has a voltage regulator on it that'll do 5 to 18 volts or something.
So imagine that my friends and I were going to a repeater site, and we need to okay, well, somebody kick one of the cans or turn the knob, not knowing it's not a knob you need to turn, or a number of other things that happen, at a repeater site. So we might need to tune those cans without lugging them back, to a workbench. So, that was it wasn't a very, rational, I figured this out down to the nth degree. But if that went portable, then the Bodnar could go portable with it, whereas my other one really couldn't.
No, and another thing too, though, is hitting on the fact that it is a much wider variable frequency output, whereas the Trimble based ones, or any of the ones that are meant for site installation, and the Trimble ones, an interesting piece of history about these as well. Like, there was a time when these Trimble GPS units were, as you said, they were being pulled off cell sites. They were being flooded on the surplus market. You used to be able to get them, I think, for under $100. Mm-hmm. Then there was a time where people realized, hey, these are really good. And the market shot the price up into the $300-$400 range. And now I notice they're starting to come down because some other manufacturer is the hot manufacturer du jour. And now their stuff is the expensive stuff and Trimble's old hat.
Well, that Trimble device, now I have the Chinese circuit that I built, or box I built. It simply uses, it's not just a Trimble chip, but it's the Trimble GPS with another circuit built around it to put the outputs and other things there. So I want to distinguish for the listeners, the Trimble, and I forget the model number, that was exactly what you said. And it's kind of a little bit old hat. You know, it's like my Flex 3000 with Firewire versus the new. I mean, hey, it is what it is, right? So, but I want to make another point. Apparently, Dave Jones gave a teardown on one of those, and that drove the price up.
Yeah, he's good for that.
Yeah, I mean, I appreciate it, but when he points in a direction, a lot of us lemmings, tend to go in that direction. But your point certainly well taken, and I splurged perhaps a little bit by adding the Bodnar, but I did it for those reasons of compatibility.
Now, one other thing I'll point out, so I don't have a time reference on my Workbench. It's something I've been heavily interested in. If I were to buy one tomorrow, I would buy the Bodnar. But another useful thing about this as a tool on your Workbench is, so going back to my, as I've mentioned many times, I'm a big fan of the AirSpy SDR receivers.
Right.
So over the last year, they've added a feature where they do onboard hardware frequency calibration. Mm-hmm. And it's not super extensive. Like if you have an Elecraft KX3, there is a frequency calibration procedure that literally involves putting your radio in your freezer and then putting it under like a hot air gun and getting a wide range of temperature, situations and making calibrations at various temperature points, because it's, one, ppm adjustment isn't necessarily going to cover every situation. But with the AirSpies, there's a calibration factor on board, and you can use one of these Bodnar boxes for the 10 megahertz signal to get what that calibration factor should be. But if you think about just in general for radio stuff, you have a signal source that you could use to do a lot of radio tuning, calibration, repeater site tuning and calibration. I mean, on its own, it is a low power, very accurate signal generator. Right. Absolutely. And the ability, and I think it's through software that you would then, you hook that in to the computer and it will read the USB port, if I'm remembering that right. Yep.
Then you've got that interface that you can kind of do that, if you will, on the fly.
Yeah, and it's frequency agile as opposed to these Trimble sources. It's 10 megahertz is what you get.
Now here's an example. The solution that I plan to do before I got the Bodnar is, I would say I got 10 megahertz. Wow, this one, my 8640B, it needs 5. Well, I bought on eBay for little or nothing a Wenzel frequency divider, and it had some really good specs about how accurately it divided the frequency, et cetera, et cetera. And so I kind of built the cables on it and all that. That's why I said I've got to figure out how to package this Chinese, Trimble-based Chinese box, because if I want to feed that 10 megahertz out of the video amp into the Wenzel frequency divider, and then that into my signal generator, my HP 8640B, which requires a 5 megahertz reference signal as opposed to a 10, you've got those at best kludges to get there, whereas, as you say, the Bodnar is frequency agile, software controllable, and that's a very nice touch.
Yeah, that is really nice. And like you said, it's a tiny box. It's handsome. It travels easily. It has a wide range of input sources. And what's cool is, it's just an SMA connector for the antenna. Like you said, it comes with a patch, or you could buy one of the commercial like or outside radome, style higher gain antennas. GPS is 1.5 gigs, right?
That's the ballpark.
Yeah. Again, obviously, like every satellite above actually transmits on a different frequency. They all have a time that gets transmitted with them, and then half of what the GPS receiver does is measures phase and things like that to actually do the positioning. Correct?
Right.
Yeah.
Right. Exactly. And see, because I've had students ask me in class, well, why don't they interfere with one another? And of course, that's the answer. That's been designed in them so they wouldn't interfere with one another. And it's a little like Whisper. On the timing for that is how often does Whisper transmit and then listen? And so it's a similar, type of approach. But Jeremy, the reason that all your listeners need one of these very accurate clocks is so they can know how late they are when they tell their XYL they're going to be somewhere. I mean, you need to know that very accurately. So, well, what I've also added, and this I will say, this was something that just intrigued me so much. Way back in the day when I was 20 years old, I had built a college FM station, a big 10 watts. And that station is still on the air 45 years later, and they have 50 people that work there. I'm really kind of jazzed about that. They're going to do a little history, and my former roommate and I are going to go back during homecoming, and we're going to do from 9 to 3 and play music of the day and talk about
what's the station call letters.
Well, the current call letters is WGUR. Their slogan is The Noise. Well, back in 1974, when we were about to finish that and get it on the air, I left to go to graduate school about 2 weeks before it signed on for the first time. So my roommate, Greg Duckworth, actually was the first station manager. It was WXGC 88 Rocks then. I also got to play with someone else's money and built a commercial AM station for these three partners, a Ford dealer, a person who owned a dry cleaner, and an attorney. They threw their glasses into the fireplace one New Year's Eve and decided they were going to we're going to plant a turnip patch, or we're going to build our own radio station so the only station in town doesn't soak us on our ad cost. And so they threw their glasses in the fireplace and all shouted radio station. So they didn't plant a turnip patch together. They built a radio station. And that boy over to the college named Frank is who they hired to build that AM commercial station. So I actually built 2 radio stations very young in life. Was the news director and had my 2 best stories stolen by the AP editor in Atlanta. And I said, I'm going to another career, went to become a college professor. Well, all that is to say, I had a little bit of a background and held an FCC third-class commercial license, which just meant I could light the lamp in the morning. So I've had an interest for a long period of time in commercial broadcast frequencies and whether they drift and their accuracy. And as I was tinkering with this area and trying to learn what I could, I ran across what is a beast. And I mean by beast, it's like at least 80 pounds. It's an HP Hewlett-Packard 3586 selective level meter. I have the Model A, 3586A. It goes extremely low frequency, up to 32.5 megahertz. Now, it's got a frequency resolution specification of 1 microhertz up to 100 kilohertz. Pretty good.
Yeah.
Now, it measures phase jitter and things like weighted noise, noise with tone, and some stuff I don't fully understand yet. And it's very accurate with an external 10 megahertz frequency reference. And it's given our new band allocations, Jeremy, It's very good for very low frequency reception measurements and for broadcast frequency compliance. Those who know George Thomas, who lives about 3 miles west of me, George manages about 8 radio stations. He's the RF engineer, and so he's always running around getting transmitters back on the air. And I asked him what he uses for frequency compliance, and he says, I just take a frequency counter when I'm close by. Well, the frequency counters that you take with you can get overrun by RF. And so I said, if you ever need something to me to check one, since they're all kind of local, I said, I'll put it on this selective level meter, and I'll give you what it says for your report if you want to. Well, this thing is interesting. Why did they build this thing? They didn't build it for us hams or even RF. But a lot of people don't realize single sideband was what the plain old the POT system, our old copper wire telephone system, used single sideband because it could squeeze in more voices. Mm-hmm. And so it was built by Hewlett-Packard for the phone company and for them to use to do test and measurements on plain old telephone system. And they had 3 different models, and I have the A model. But I wanted to use it with the Eclipse to do some propagation stuff. It's HPIB programmable. For listeners that don't really know what GPIB or HPIB, GPIB is a generic version of Hewlett-Packard's interface. Looks like an old parallel port printer back in the day. And so you can program it, and there's software you can interface with it. And there's a program called Argo, ARGO, and there's several things. If one Googles the HP 3586 SLM and Argo, you'll see some websites where these folks have done really elegant explanations of how you can do some really, really cool and very accurate propagation measurements and things like that. So it's a very accurate frequency measurement device. It's basically, you can listen to 40 meters on this. I mean, it's kind of one of these things where you go into an antique store and you see the ugliest piece in there, but you have to have it. That purchase for me, Jeremy, was a little bit like that. I had to have this thing, given my background. And so I haven't really gotten into it yet. I hope I don't have a hernia from lifting it and putting it in my IT rack. It's very heavy, and I put it on a double-mounted shelf because of the weight. And so that's on my workbench to get to learn more about it, to bone up with it. But you can pick these things up. I got one for $40 in shipping. I mean, why? Because even the phone company doesn't need them anymore.
That's amazing.
So anyway, that's kind of what's on my workbench with regard to frequency reference and why I spent the time as I'm building my workbench. I knew I needed to have a good frequency reference. I will get a good voltage reference. There's a great one over in the United Kingdom that this guy has built, and I think it's Arduino based, and it's really cool. It's a couple of $100. It's expensive. So I bought a $12 one from China. And so I'm building these tools that will help my measurement instruments be as good as my pocketbook will let them be. I guess that's kind of a punchline to what I've been doing. And I'm doing it, to have a better workbench and to continue to learn and do things that you guys talk about in your podcast and some others. So that's kind of my story. I'm going to say that you are definitely a man after my own heart, because I live in constant fear of compound error. Right. I hear you. As I got into 3D printing, I mean, that's one of the things that, even I started exploring woodworking, and when you talk about, things have to be square, right? I mean, a cabinet maker at the end of the day is a woodworker who can guarantee things are square over long distances, right? I mean, right. And all of these things add up. Actually, one of my favorite things is if you have
if you have an AirSpy, and maybe other dongles do this as well, but there's a frequency calibration utility you can get, and you have a lot of options even if you don't own a GPSDO. So you could hook up a SpyVerter and tune to WWV on 10 megahertz. Of course, at that point, you have two oscillators in the chain, but you will be as accurate as the SpyVerter would be. I've also referred previously that all digital broadcast signals, terrestrial digital broadcast television signals, have something called the ATSC Pilot, which is 309.40954 kilohertz offset to the right of the left band edge. And that's actually really accurate because those TV transmitters, just like cell phone sites, are, investing in high-end time sources. The only error you're going to get is based on, where you are in phase, based on how different or far away you are. So I've tuned my receivers, and it kills me when I go to tune in local repeaters to see they're actually off, a little bit.
Right. Well, and, and I'm one of them, but all kind of people put up repeaters. And I don't mean that pejoratively, but people would, let's be kind and say various levels of training and preparation, put up repeaters. And so repeaters vary. I was on the Southeastern Repeater Association group for Mississippi. I was the vice director. And so I got a really good look at, looking at what they said they did and all that, and then riding around and doing a little bit of those measurements in the field. And so I hear you. And the compound error, one of the things that I benefit from is my two friends, Tom Brown and Thomas Gandy. And Tom Brown has had a lab before he closed that business. They had an R&D business, and the angels in the angel fund kind of redirected the money out of what they started the business to be. They went from MCOM-based antennas. They built an ironing board looking antenna that was very, very broadband and built to mount on emergency management agency vehicles. Kind of like, hey, we're going surfing, we got a surfboard on top, but it was a broadband antenna. And some others products, and then the angels in the angel fund redirected into biofuels, and they lost all their money. So he closed his R&D company, but he got some cool things out of it, like Roday and Schwartz equipment and some things. Mm-hmm. So I picked up for not a lot of money a Tektronix 496 spec analyzer that goes up to 1.8 gigahertz, and I found in an unopened box, never opened, never unsealed, a tracking generator to go with it. And Tom wanted to smell a Tektronix box. It was new and had never been opened. And so Tom has my spec analyzer and tracking generator out on his workbench, and he's kind of calibrating it for me. And so my next round of things will be to calibrate my counters and I'll probably add another frequency generator. Some of the later models of HP have come down, and some of them they have like built-in two-tone tests and one thing or another, and we'll do a little higher frequency than the 8640. But anyway, that's kind of what you and I have a lot of kindred spirits on this, and I want to get my equipment calibrated to reduce that compounding error. Come back to the punchline.
Yep. Well, I'm going to ask one final question before we break to close out, and it's a concept that, especially with when you have clocked digital signals, and again, there's probably an oscillator in your mouse in your computer. Clocks are so important for so many things. But, we talked earlier about drift, which has to do with how stable is the frequency source over a period of time in relationship to environmental factors such as temperature. So that one's easy. But two other things that you will often hear, and I know they're especially important when talking about time, are jitter and phase noise. Can you tell us what jitter and phase noise are?
I have a lot to learn on that. I understand the concept of phase and I understand the concept of jitter. When you look at those factors together and you start looking at the drift on this, I'm not sure I fully grasp it, but I'll be candid. So I'm learning on that. One of the things that I did, I mean, you have to forgive me, I've been a college professor for 40 years. We have things called libraries where we have a lot of books.
Those are buildings that weigh a lot.
So what I did is I began collecting a lot of the technical Workbench related reading paraphernalia. Like if you're familiar with Joe Carr wrote probably 25 books, things like test and measurements to loop antennas to what have you. And so I have, by my last count on my Dropbox account, including the ARL stuff that you buy in digital form, the open source magazines that, go back to yesteryear, and then things I bought like Electric Radio and, those kind of things. I have about 3 gigabytes or more of technical material. And so one of the things I'm doing is I'm putting myself on a curriculum so that I'm focusing on some general topics and reading all I can and trying to learn. And so that's where I am, Jeremy. I'm not really able to give you a good answer. I understand phase and I understand jitter, but when you begin to put those together and to look at them over time, I understand Allen deviation, and I read some of the time nut stuff, and they get into arguments and debates, and I try to keep up. And I feel like the student that sat in the back of one of my classes and barely did the reading, that I was lecturing on. So the shoe's a little on the other foot. I'm getting there, Doc. I'm getting there. So I'm trying to learn. That's where I am learning. And what's fun about it is I began this journey when I was 8 years old and listening to one of my grandmother's pieces of furniture in the living room that had this winking eye that would wink at you when you tuned the signal in. And I began listening to distant AM stations. And by the time I was 12, I think, I was in the international, the IRCA, the International Radio Club of America, something like that. And I built a ferrite-based loop antenna with a Faraday shield. And, I was 10 or 12 years old and living on a farm, you'll laugh. I literally soldered some things by taking hot coals with it.
Wow.
And melting the salt. I'm not giving you a 20-mile in the snow speech here. I'm really not.
Back in my day, we didn't have soldering irons. We had soldering coals.
Well, I actually did some of that because I didn't have a solder. I was 12 years old, So the point I'm getting is I've had, a long time coming to get a workbench and to kind of focus on some stuff that I never took the time when I was chasing grant money, teaching classes, writing papers, and slaying all the academic dragons that, you have to be successful as a college professor. So that's one of the things that, while I'm not fully retired, that's one of the things I'm doing, if you will, during my retirement years, is I'm doing a lot of that stuff that you got giddy about with your project that you've done from start to finish. And that's why we do this, because we get jazzed over that, whereas someone else might get jazzed over, I'm looking out at a big reservoir here and people hunt everything from we have once a year alligator hunting in the reservoir to competitive bass fishing and all that. Some people get jazzed by that. Well, you and I and our listeners get jazzed over this kind of stuff. So I'm spending a good bit of my time these days learning. And that's kind of where I'm at with it. And so I'm not up to your last question to give a decent answer, but I will be.
Well, that's fine. We'll have you back on to talk about it once you figured it out. So we'll take a quick break and then come back to say our goodbyes.
Making your own printed circuit boards can be easier and cheaper than you may think. Eagle PCB tools are used by professional engineers, educators, and hobbyists all over the world. With thousands of component libraries, schematic capture, and board layout tools, Eagle is the best choice for your next project. Check out their board design tutorials on YouTube and free monthly webinars. Download your free copy today at autodesk.com/Eagle and start your next design project now.
So, Frank, I really want to take a moment and thank you for spending this time with us and being such a gracious listener and a fan of the show. I mean, this is a topic that a lot of people may find completely boring, but I think the accuracy of reference sources is just such a cool thing. And the fact that, I mean, could you imagine 30 years ago that you would be able to buy a device that receives signals from outer space to give you accurate signals in your lab?
Well, 30 years ago, you would have been, the person with the tinfoil around your head and that kind of thing. But it's hard to imagine. We are at a fast eddy in the stream of discovery. And as you and George said earlier in this podcast, that all the stuff on YouTube and the maker world and just what's happening, everything from the, in quote, cheap Chinese circuits that are coming out, which simply make it affordable.
That's right, and accessible.
It is a tremendous period of innovation and discovery. And that's an exciting time to be alive and to do a lot of this kind of stuff. I mean, it truly is, because just, I probably have $4,000 into my Workbench that, conservatively speaking, if it were all brand new, would be $250,000.
Yeah.
Because a lot of the HP stuff was terribly expensive.
Oh, yeah.
Tektronix was not far behind that.
Still isn't.
Yeah, right. It still isn't. But the prices on a lot of these things, they still do what they do if they've not been abused. And even if they've been roughed up a little bit, many of them can be reclaimed. I bought that 496 spec analyzer first, and the guy just got into recycling and he didn't pack it, and it came, so it wasn't working. It was bent in several places. And he was kind enough to give my money back and said, keep it. I don't want to pay to have it shipped back. So I bought another one. Well, I now have a junker. So, I mean, if any of the parts go out in that spec analyzer, I've got one just like it, that I can recover some of the unobtainium parts that we might face sometimes. So it's a wonderful time to buy things that you and I and many of the listeners could simply never afford, on a home Workbench.
All right, so Frank, if folks wanted to know more about what you're doing, or wanted to check in with you, is there anywhere they could go online? Are you active on social media?
I am. Of course, I have a Facebook account, and I'm on LinkedIn, and I have a blog at K4FMH.com. It's called Fox Mike Hotel, my initials. And really, I haven't posted anything in about a year, and there's a couple of reasons for that, but I'm about to, I'm going to talk about some of my adventures in building a Workbench and what I'm doing. I've done a couple of things. I was assistant director for the Delta division of the American Radio Relay League, and I spent several years under two directors and did surveys for them. And one of the things that I found in these surveys, and see, I did that for a living. I started 2 survey centers. I've done national surveys for Associated Press and many other folks, have a chapter in the Handbook of Survey Research, yada, yada, yada. So I was very equipped to do that for them, and I did it, for free and all that, as far as my time was concerned. What I found, which would be very of interest to you and George and your listeners, is that there's at least 3 groups of hams that seem to distinguish themselves. One are, and I mean this with affection, the shackle on the belt MCOM folks, that they really want to serve the public and they want to help out in bad times like we have right now with these hurricanes. And that's what their devotion is, and that's what they get jazzed up over. And there's that group. And then there's another group that chases DX, and they are not too different, from contesters. There's a lot of overlap. You do a lot of DX in contests sometimes, so you got the DX contesters. And then there's a third group, and they're experimentalists. They don't get on the air much, and others will say, well, you're not active. Tell me Martin Jew is not active as a ham.
Exactly.
He has the world's largest amateur radio manufacturing company in Starkville, Mississippi. And yet he's active primarily from his car doing CW. And so, Martin has forgotten more than I will ever know. And, he would be doctors you, but you know why he didn't finish his dissertation? He had a company that took off. And so Martin didn't finish, and he taught at Mississippi State in electrical engineering. So the point I'm getting at is that what your podcast, yours and George's podcast, focuses on may not appeal to every ham, but it appeals to a significant subset. And you'll find that over the career of a ham, some who get tired of chasing DX, or they've reached that sort of asymptote of, I can't get any more of these rare DX entities, so there's no fun in this, they'll have something that breaks, and they'll try to figure out how to fix it. And then that leads them into understanding why it broke and why the fix worked, and they'll drift into experimentation. And you'll have people who do income. They've learned a good bit with kind of Workbench stuff with doing the mesh technology. We now have a book on it and with ARL and some other things. But before that, you had to read some websites and go buy some $5 Linksys Wi-Fi access points and figure out how to reflash firmware and all that. So you guys have a niche that is there, and it's not going away. It may not be everybody's cup of tea. And I'll end with my punchline, because you always get into my kind of ham, your kind of ham. And Jeremy, I've found out the Holy Grail. You know what a real ham is? I've found the answer.
All right, what's the answer? Enlighten us.
Any ham with a valid license.
There you go. I love it. Well, folks, thank you very much for spending the time with us and Frank today. If you want to know more about Ham Radio 360, please visit us online at www.hamradio360.com. You can follow me on social media. I am very active on Twitter. My handle is at KF7IJZ. George, it can be followed at KJ6VU. Frank, what's your Twitter handle?
At Frank M. Howell.
With 2 L's.
Correct.
All right. So 73s until next time. Again, our thoughts and prayers are with the folks who have gone through or going through Irma and its remnants. We'll be back next week with an episode of Ham Radio 360 next Tuesday and another episode of the Field Radio Podcast on the following Thursday. 73, everyone.
W4AUE, we got a breaker. Okay, Ken, I'm not copying him. Please pick him up if you can.
15DOA, Don, you have any traffic? 15DOA, you said something a minute ago. You have any traffic, Don? Over.
Okay, well, I thought that was N5DOA trying to check in.
Whiskey 4 Alpha Uniform Echo, I thought that was Don and Harrison Oscar trying to check in, but I'm not coming, he's not coming back.
I thought it was November 5 Delta Oscar Alpha. Okay, Ken, thank you. AG6SE from W4AUE. I can barely hear him. He is on the instant messenger. I'm seeing him off and on. If he has any traffic, Don, call me now. Over. Nothing heard. N5 Delta Oscar Alpha. If you have traffic, call back here in a few minutes. You're up and down. This is W4AUE, net control for this hour, the remaining few minutes here of the Saturn net. We're activated for monitoring for traffic from Hurricane Irma area. If you have traffic for the net, please call now. Nothing heard. This is W4AUE, net control for the Saturn net. We appreciate the station standing by and helping us keep a clear frequency monitoring for traffic from the affected area. W5
going with the hurricane net. This is Kilo Zero, Bravo Oscar Tango for the hurricane net. This is a directed net. This net operates to provide weather data for the National Hurricane Center and to provide advisories to the affected area of Hurricane Irma. As a secondary function, this net provides backup communications for official agencies such as emergency management agencies and emergency operations centers. We also help non-governmental agencies such as the Red Cross and other vital interests in the affected area of Hurricane Irma. Health and welfare traffic is being handled by the Saturn net. They are on 14.265 megahertz. They operate from 9 a.m. Central Daylight Time, 1500 Universal Time, to 6 p.m. Central Daylight Time, 2300 Universal Time. They will be handling outbound traffic from the affected area only. Additional information regarding health and welfare nets and information can be found on our website homepage. That is hotelwhiskeyNancy.OscarRomeo Golf. I say again, hws.org.
As may be required. If you have traffic for this net, call W4AUE now. Standing by.
November 5, Kilo Delta Alpha, looking for Saturn net. Anybody on?
W4 Alpha Uniform Echo on the Saturn net. Station calling, please repeat your call sign slowly and phonetically.
5 KDA, looking for Saturn net. Anybody on in 5 KDA? Okay, I'm not hearing anybody here. I've got health and welfare for St. John Island. Over.
Roger that. If you can work and pick it up.
Yeah, the call is November 5, Kilo Delta Alpha, Nancy 5, Kilo Delta Alpha. Name is Gary, Golf Alpha, Romeo Yankee. I've got traffic for someone on St. John. That's my doctor's son down there.
N2KI from W4AUE. This is the Saturn net, monitoring for traffic of the affected area of Hurricane Irma or the path of Hurricane Irma, taking traffic outbound from the area and looking for information with regard to weather conditions on the ground. This is W4AUE.
N2KI and 5 KDA. Okay, this is not going to work. I've got his name. I do not have a phone number for him. I do not have an address for him. All I have is an area that he's in, and since I can't fill out the form completely, it will not take it. I've got his name, and I've got the area on the island that he should be in, but I do not have an exact address for him. His father does not have an exact address for him. It says he does not have an address such as what we would have here. what the form requires, I do not have them. St. John Island.
Yeah, go ahead. Okay, roger that. Well, people on the ground are being instructed to list their condition on that site if they can with regard to they're safe and well. So if they're reporting that they're safe and well, he can search with the name and it should pick it up. If they haven't reported or can't report, then it won't be of help. There are two other nets that are operating, the Maritime Mobile Service Net on 300 and the Hurricane Watch Net on 325. You might want to run him over there and give it a try, see if they'll take it with just that amount of information. Unfortunately, Saturn doesn't have the assets, and we are working with the Red Cross via their website, so that's the situation we're faced with today. W4AUE.
Just the name. But thank you very much, and I'll probably be on. Well, this is Thursday, but this is the first Thursday for assistant agencies and all this stuff to check in on our Mississippi Section phone net tonight. So I will be there, and I will also check 3815. He had to stay there. I don't know if he's a doctor or what, but apparently he had to stay there during the storm, and just trying to find out about him. I thank you very much again, N2KI, N5KDA. And once again, I appreciate y'all's time and letting me get in here on y'all's net. Thank you very much. N2KI, N5KDA, out.
N2KI from W4AUE. Thanks, Anthony. Net has been active, and they usually run net logger, but I'm looking at the net logger site, and it's not showing them as being active right now. I don't know that that necessarily means they're not trying to operate. They have significant infrastructure damage down there on some of those islands. I know the first reports from Antigua and Barbados is 95% destruction of, or 95% impact to buildings and structures on the island. So it's been pretty rough. I think their entire cell phone infrastructure is down as well. So if he has no luck, come back. I'll take the traffic personally and try to put it up on some other net